Oh, you need to pull it out, actually.
Loud microphone. All right, good morning, everyone. We are going to get this generative design session started with two lightning talks, which our wonderful SV Kevin is playing for us. Thank you, Kevin.
Hi everyone, my name is Xiaoguan.
Oops. How does audio work with this?
So now we're going to debug
Let's
audio.
see. This is HDMI. Oh. Yes, that's a good manual way to do it. This one, okay.
I'm a researcher at UIST Interesting Lab,
Okay.
working.
Let's start over.
Hi everyone, my name is Xiaoguan, and I'm a researcher at UIST Interesting Lab, working with Professor Juho Kim. I'm looking for a PhD opportunity where I can do exciting research about building systems that can change people's working paradigm more efficiently and effectively. In this year's UIST conference, I'm going to present our work, WeTune, a system that can facilitate webtoon authors' communication and help the writers to fix images using simple interactions and enable them to convey their revision intention to the artists. Recently, I investigated an interview study to understand how would visual artists adopt DALL-E to support their tasks. In the study, some people thought DALL-E is just like Google image search and it does not produce novel and intelligent images. About my personal life, I like swimming, and I'm a big fan of the soccer team, Tottenham Hotspur. Thank you very much for listening, and please contact me via email. I would be really happy to chat with you.
Hi, I'm Katie Wu. I just finished my undergraduate education at the University of Chicago, and I'm currently a research assistant at the Human-Computer Integration Lab, advised by Professor Pedro Lopez. I'm interested in the application of HCI in gaming, art, music, and storytelling. At UIST this year, I'm excited to present my first contribution to HCI research on the paper Prolonging VR Haptic Experiences by Harvesting Kinetic Energy from the User, led by Shenyuan Teng. This approach provides on-demand vibration and electrical muscle stimulation without power cables or a battery. When the device is about to lose power, the exoskeleton fitted to the user's arm provides resistive force feedback and harvests the user's kinetic energy. Accordingly, the VR experience renders a scenario that requires resistive forces, such as rowing a boat. I'm currently working on a research project in sustainable prototyping. In the future, I want to explore how HCI can impact how we create and experience media. I'm really excited to connect with other researchers who have similar interests. I'm also looking for PhD or industry positions. Thank you.
It takes a while to power on. So thank you for playing the lightning talks. And again, welcome to the session on generative design. My name is Jingi. I am a PhD student at Stanford University. I'm delighted to serve as your session chair. We're coming up, okay. Just to remind you, Hyung Kwang, whose work is the fourth paper in the session, is looking to apply for PhD programs, not this cycle, but next cycle. So let's get this session started. I invite Vivian Liu up to the podium, who is going to present the work Opal, Multimodal Image Generation for News Illustrations, the first paper in the session.
Hello? This on?
Other one. That one's for computer audio.
Hi. Is this one on?
You can have my mic.
All right, cool.
Okay, you have to hold it, which will be annoying.
That's okay. Hi, everybody. Good morning. I'm very excited to be here. In line with the two lightning talks, today I'm going to be giving a presentation that's kind of at the intersection of text-to-image AI as well as illustration. Okay, let's get this party started. Hi, my name is Vivian Liu, and I am a third-year CS PhD student at Columbia University, as well as a National Science Foundation Graduate Research Fellow. I can project. Is this better? Yeah. Okay, yeah, so this work is done in collaboration with Han Chow, who is now at University of Toronto, as well as my advisor, Lydia Chilton at Columbia University. I'm presenting today Opal, Multimodal Image Generation for News Illustration. If at any point my sound is not enough, just give me a thumbs up in the back and I'll raise my mic. So the topic for today is text-to-image AI. So text-to-image AI are a new and powerful way to create images. Many of you might have heard of DALL-E or Stable Diffusion. So what these models do is they take in text as input and they produce images as output. So here's a pretty good example on the screen here, where given an input prompt, ocean in the abstract art style, we can see that the AI-generated image is able to capture both that subject as well as the aesthetic language of the abstract art style. So in prior work, we found that prompts can really express a wide range of visual language. They can capture subjects that are both abstract and concrete, so there's universe and intelligence, but also things as concrete as dog or ocean. And they can really elicit and imitate a number of different art styles as well, spanning different cultural traditions and different time periods. However, they may be powerful, but they still have a lot of core usability problems. And one is that generation quality tends to vary quite widely. So sometimes we might get lucky and we can get consistent results like the one on the left, but other times we might get results that are more uncanny and distorted. So for example, here on the right, we have happiness in the style of Dada, and I'm sure that nobody would like to really use that. So we're looking at text-to-image AI in the application area of news illustration. So we decided to look at news illustration because we thought that news illustrators might really benefit from the efficiency and expressiveness of these AI models, because they often have to work under a lot of time pressure because they're in journalism. And we also thought that news illustration is actually a classic instance of a text-to-image problem. Here's a couple of examples of what I mean by news illustration. We engage with them every single day when we're reading the news. So to this end, we present Opal, which is a system that guides users through a structured search for visual concepts. So Opal is a portmanteau of two words. The first is oeuvre, which stands for body of artwork. It's a term borrowed from the art world. And the second term is palette. And when you combine those together, you get Opal, which allows users to go through this structured search and then find all the AI artwork in its totality at the end of the system. Okay, so what Opal is more concretely is it is the combination of two AI models within one workflow. So on one hand, we have GPT-3, which streamlines prompt ideation, and on the other hand, we have VQGAN plus Clip, which generates text to image. So first off, we have GPT-3, which interacts with the news article that's being passed in, and then it creates prompts that are structured. They're structured to be a subject in the style of some style, and there's 4 parameters that can change: different keywords, tones, and icons and styles that relate to the news article. And then VQGAN plus Clip then generates text to image and can create some potential news illustrations. Buffering. Well, I'll talk through what you're supposed to see in a moment. Okay, so let's all imagine, let's do Wizard of Oz. So first of all, when you have a news article that's passed into the system, and then afterwards we have GPT-3 come up with a number of different keywords. So for example, if you had an article that was about how climate change is speeding up the speed of sound underwater, GPT-3 would come up with a number of keywords related to that. So it could come up with keywords like global warming, it could come up with things like biodiversity. And then okay, so you can see here that given an article like climate change speeding up the speed of sound underwater, you can get different keywords like biodiversity, research, communication, and so on. And then afterwards, a user would hit generate images, and then some default art styles would generate. So if you had a chosen keyword of global warming, it would generate these following generations of global warming in the styles of collage, painting, and photo. And this was just to give users very quick evidence of what text-to-image AI is capable of. In the next stage, Opal then would expand chosen keywords into related icons. So for example, given global warming, it might return related icons such as a sun or earth or greenhouse. And the reason why we had this expansion stage was because we wanted to give users more concrete and visualizable representations of what might be otherwise more abstract words. So again, after hitting generate images, some generations would come back. We also wanted users to be able to engage with the article at a more summative high level, so we would have GPT-3 summarize the tones that would come from the article text. So for example, about this article for global warming, different tones that came back were dread, fear, horror, terror, and panic. And again, we had this expansion step where we would take different tones and produce related icons for them. And of course, when we're generating these images, at first they only saw default styles like photo, painting, and collage. But afterwards, they had a style exploration stage where they could interact with 100 to 125 different art styles that we had in the back end of Opal. And the way this would happen is a user might choose a subject like a whale, and then some recommended styles would come back. So for example, things like oil painting, manga, fisheye photography, and documentary photography were things that were returned. The way we did this was we had a semantic search over some GPT-3 synthesized art knowledge. And again, this would allow users to have more freedom and control over what styles were expressed. And we also had an area where users could put in whatever prompt they wanted to as well. Because we depended pretty heavily on GPT-3, we also had to evaluate it on its associative knowledge because we were doing a lot of bespoke tasks. So we did an annotation study where we evaluated human performance versus GPT-3 performance. And so an example of this would be, we would ask a person for 10 different keywords for a news article, and at the same time ask GPT-3 for the same. What we found was that GPT-3 performance was comparable to human performance for every single task, even for ones as bespoke as coming up with different icons to visualize a tone. What's key to note is that humans outperform GPT-3 in all of these tasks. But the humans tended to take 25 minutes to perform all of these tasks, but GPT-3 could do all of this in under 5 seconds. So we validated that it was good to include GPT-3 in this performance, and after looking at all of the tasks in isolation, we did a within subjects evaluation of Opal in its totality. We looked at the full version versus an ablated version, which is just a text box, and we argue that this is valid because even the state of the art like Stable Diffusion and DALL-E still only provide text boxes. What we found was that with Opal, users were able to find over double the amount of usable outcomes. We see this illustrated in the way that the right bars are higher than the left bars for every single grouping of participants. So we see that, across, and we also see that in the way the proportion of the green bars is higher. The proportion of the green corresponds to the amount of usable outcomes. Qualitatively, we found that users use generations in 3 key ways. Some of them took them as is, but most often they took them as visual assets. So it wasn't that people would just generate these text-to-image generations and then that would be a full stop. They often did a lot of remixing that I'll show in future slides. And they also really like to take these generations as just conceptual ideas. So for example, to illustrate an article about healing in the times of COVID-19, someone liked healing in the Conte crayon drawing style, but other people would just like different abstract things like an animal in the wild in the style of painting. And an example of how illustrators would make visual assets is shown here. So here we can see how a lot of people would take different sets of compositions and remix them into their own, using the generations as design materials. Other people would just correct for different artifacts and just take away the distortions. And some people would just add simple filtering to add complexity to the results. overall, participants really enjoyed Opal. They liked that it's good for cherry picking, and they said that, oh, it's great that I can just do this forever until I get the ideal one. Some did note, however, that this type of paradigm would encourage more reaction than intention. So this participant once said, I'm reacting more to what it's generating than me proactively putting in things. But nonetheless, News Illustrator participants really found Opal highly useful. Even when they already had the expertise, even when they already had a concept in mind, they found that they could still build upon it using Opal. So for example, one person for that article about healing in the times of COVID-19, they immediately thought, I'm gonna draw a glowing heart. But after using Opal, they just had better clarity on what the background could look like, and they had different inspiration about the color palette, the texture, and more concrete ways to represent that idea. So now coming to a conclusion, Opal is really able to structure the exploration of text-to-image generation. And one of our main takeaways was that generating more images really helped users come to better outcomes. And at the same time, it helped them really better understand AI models as well. The more they saw, the better mental model they have of what the text-to-image AI could do. At the same time, we showed that multiple general-purpose AI models can be integrated into one workflow. VQGAN plus CLIP, as well as GPT-3 worked really well together, even though they have very different computational sensibilities. And lastly, I do know that there is a lot of questions and concerns around what will happen to artists and a lot of copyright concerns, but I do think that this paper can be considered a case study for how illustrators actually could be augmented with generative AI. And this human in the loop and AI in the loop workflow was really a great case of synergy. So this is the contact information in case you have any questions. Now I'm open for any questions, and I'd really like to thank everybody for bearing with all the mic issues and so on. Hello.
Okay, I think we have one mic for this session. Can you maybe try speaking into this one? But please, I will hand the mic to you. Raise your hand if you have a question. We're going to take these 3 questions. Also, when you speak with this mic, don't touch the bottom of it. That's why we have the issues.
Hi, thanks for the great talk. Have you ever observed any kind of like aesthetic issues or any shortcomings of using this generative AI in the News Illustrator, and do you have any insights for that? Thanks.
Yeah, so I believe the question was, have I ever observed any aesthetic concerns? There's still definitely a lot of failure modes for text-to-image AI models. I have a prior paper that kind of characterizes these failure modes. It was Chi 22. For example, say you want to do the naive approach of just putting in a news headline. Oftentimes what it might do is it might just write out text, but the text is like fake text and it's not necessarily like from a real alphabet. So that's one example. It might hallucinate text. And at the same time, it's still not great at composition. So for example, if you do a face, we're really good at recognizing faces. So things will still look uncanny.
Hey Vivian, this is Bala from Microsoft Research. Thanks for the great talk. I had a quick question. So in your talk, you mentioned about illustrators putting in an input article and getting inspirations from that. But were there instances where, and that is very article driven, right? Were there any instances where the illustrator kind of knew what they wanted to create and then gave different prompts that might not be related to the article? Like in your example, say, you said one of the illustrators wanted to have like an image of a glowing heart. Did you find that sometimes it was illustrator driven and not necessarily article driven?
Yeah, and I think that that's a great instance of where the human provides all that visual expertise and the visual eye to know that even if it's very conceptually distant from the news article, they're still able to make it relevant. So for example, some people would explore like animals and the painting art style, or they might just put in whatever, but nonetheless, they would have the visual eye. I will also say that a lot of people would put in random things at first just to get that mental model of what the AI could do. So that's why it's always very important to have that final stage in the workflow of just that text box so they can put in whatever.
Hey Vivian, great talk. My name is Matt Bremer from Tableau Research. Curious about the inputs where people found the results to be unusable. I was wondering if there's any commonality in the structure or content of the articles that were fed in that stage. Like, what is it about their themes or just the flow of the article? What was unique, if there was anything unique about those failure or outcomes?
Yeah, a lot of times it's about the alignment with the article. And so, for example, they might get a lot of great generations, a lot of beautiful aesthetic ones that might be nature related or so on, but they wanted to connect on very specific qualities. And so they would keep looking for things that had a dark tone or things that would have a certain composition. But these very fine-grained control details and composition details are things that DALL-E is still not good at. And it's things that might be addressed in future work like image prompting and in-painting, but it's not something that's easily achievable with just text prompts.
All right, let's thank Vivian for her talk and great Q&A session. The next paper is Social Simulacra, Creating Populated Prototypes for Social Computing Systems. And we have Jun-Sun Park here, who will be presenting it.
Okay, does the mic work here? Perfect. Cool. Hi, everyone. Thank you all for joining. My name is Jun. I'm a third-year PhD student in the Computer Science Department at Stanford. And today, I'm really excited to share social simulacra, a method of creating populated prototypes for social computing systems that I developed with my advisors, Michael Bernstein and Percy Liang, as well as Lindsay Popowski, Carrie Kai, and Meredith Ringo Morris. For many decades now, we have designed and deployed countless social computing systems. But the irony is, even today, as more and more people populate these systems, we continue to get surprised by the things that happen in them, like unexpected trolling or subtle antisocial behaviors, all the way to cases such as people congregating to spread hate speech and misinformation. But why is this? Because in theory, this issue of understanding how people might use an interactive system is something that we know how to tackle. That's what prototypes like the ones you see here are all about. But here's a challenge. In our vision, a successful social computing prototypes need to prototype not, for instance, how the user might click around different pages, but the social dynamics that might arise when the system reaches a critical mass of users, because that's where the uncertainty is in social systems. And that is an impossible task for our existing prototyping approaches. Where are we going to get thousands or even tens of thousands of diverse test users? How would we prototype the social dynamics that might arise without actually releasing these designs to a large number of people? Today, I will introduce a new way of prototyping a social computing system that tackles this challenge by generating a large number of synthetic social interactions that might arise in a populated social systems. We call this social simulacra. Social simulacra is an approach. It is an approach of leveraging the richness and the generative capacity of models such as a large language model to populate a social computing system with generative personas and behaviors for the purpose of prototyping a social system. And we will demonstrate this approach in practice by implementing it as a web application tool for prototyping subreddits that takes community designs such as the goals, rules, and moderation strategies, and translates them to a generated community like the one you see here that has never existed before, to illustrate the good, the bad, the ugly of the interactions that a community governed by these designs might harbor. What makes this possible today is this class of large language models like GPT-3. Our observation is that a large language model has seen so much of social media and human behaviors that it can generate these simulacra of behaviors and personas that are both realistic and useful for the designers. We will revisit exactly how we use a large language model to implement and evaluate social simulacra, but first, let me show you what it can do. Our tool has three core features: generate, what if, and multiverse. And they each answer to the core needs in social computing design. So first, generate. Prior literature suggests that social computing designers struggle to envision the breadth of interactions that their design might facilitate. Generate helps the designers by populating a subreddit community with generated users, top-level posts, and replies to those posts to help them envision the space. So it takes from the designer a range of design specifications, such as the goals, rules, and member compositions, and returns a subreddit-like page that is fully populated like the one you see on the right-hand side. So here's an example. In these slides, everything on the left side is the designer's input, and everything on the right side is the social simulacra's output. So in a community for connecting people moving to Los Angeles with locals, social simulacra generated a new user, Leon Santos, who posted, "I'm new to LA, what are some of the best places to visit on a weekend?" And in response, our tool generated Lucas Jameson, who replied, "I would recommend visiting the Getty Center, the Museum of Contemporary Art, and going hiking." And here's another one. This time, in a community for people interested in learning about personal finance, social simulacra generated Dane Wood, who posted, "I spent $21K to go to college and ended up with $23K in debt." But in response, this time, our tool generated Elizabeth Neal, who's a troll. Here she said, "That's a lot of debt, man. I haven't seen that much since I shopped at Macy's during the holiday season." The second feature, What If, aims to give the designers more interactive control over social simulacra to help them explore how individual conversations might be influenced. So What If takes from the designer an existing Reddit conversation and regenerates it from the middle of it, as you can see here. So imagine Maya Smith posted to a forum for WIST authors. She said, "I've been working on my WIST paper for a few weeks. I'm feeling really stuck." And to this, Heather Hernandez, who is an HCI professor, replied with a short advice. "It's normal to feel stuck when writing a paper. Good luck. But as a designer, you might want to know so you can be prepared for it. What if instead of Heather, a troll replied? Or what about an advertiser?" The What If feature answers to that precise need. So here, instead of Heather, a troll replied, "You're just not cut out for this kind of research." Whereas here, an advertiser replied with, "Click the link below to learn more." Equipped with this, the designer can now even ask, what could the moderator say in response to this undesirable behavior? And if the moderator intervened with "no advertisements, please," to the advertiser, what are some of the ways the conversation could have developed from that point on? The final feature is multiverse. And this is a feature that makes the model uncertainty explicit. With the first two features, generate and what if, what I've shown you is our tool's capacity for generating realistic content. But human behavior is inherently complex. And no matter how likely something is to happen, there's no guarantee that it will happen. And this is an important conceptual scaffold for social simulacra. So instead of just showing the designer one possible outcome, multiverse augments the previous two features, simulate and what if, by explicitly showing many possible ways the interaction can unfold from one initial state. This encourages the designer to explore the design space with inductive insights rather than over-relying on the one prediction that was made by the model. So now that I've shown you what our tool can do, let's talk about the implementation. How did we create simulacra with a large language model such as GPT-3? The core function of a large language model is to complete a prompt, which is an incomplete phrase like the one you see here that says, "Write an original social media post, colon." But the challenge here is that a compelling social media thread is more complex than what can be generated with a large language model using a bare bone prompt. For instance, if we were to generate many posts with the prompt that you see here, we would mostly see generic life updates or online advertisements like the ones you see here that are unspecific and detached from the goal of the designer. We overcome this by training multiple large language model prompts, which is also known as prompt chains or AI chains, to incorporate members' personas and community description when creating conversation threads for the subreddit we are designing. So we would start by asking our participants for a few example personas, say 10, that best describe the likely members in their community, like those shown here for a community about discussing international relations. And use these examples as a few-shot prompt to generate many more, but relevant personas, say 1,000. And then to create a post, we would take one of the generated personas and incorporate that along with the description of the community that is being prototyped into the prompt for generating posts. So here you see a prompt for Layla Lee, who is the generated persona, posting on a subreddit for sharing stories and questions about psychotherapy. And then to generate replies to this, we would pick another persona, in this case Tom Chang, and incorporate the persona along with the description of the community, and this time the original post that we are replying to. And we continue this process to generate more replies in this thread. So are social simulacra successful in what they're meant to achieve, and what does success here look like? Of course, completely generic or irrelevant generations would benefit the designers no more than lorem ipsum. Social simulacra would need to match what might actually happen in these communities. And social simulacra would also actually need to inspire the designers to reflect and make well-reasoned improvements to their designs. So we ran our technical evaluations to confirm the realism of the generated content, and a designer evaluation to confirm whether social computing designers actually find social simulacra helpful in their design process. For the technical evaluation, we used social simulacra to repopulate 50 existing subreddits created after the release of GPT-3, and asked 200 human evaluators to distinguish between the real conversations and generated ones. And these evaluators were also given the access to the content from the original subreddits, so they get a sense of what actually get posted there as the ground truth. So what do we find? So here I drew a labeled y-axis where it shows you our participants' error rate. How often did they fail to identify generated conversations? As we get closer to the 50% mark, it means our participants are basically guessing randomly. What we find is that social simulacra is often indistinguishable from the real content. Our participants misidentify the real conversations at a near chance accuracy of 41%. And we also find that social simulacra appeared more plausible than even the human crowd worker generated content. As you can see, the difference in error rate between the two conditions was quite significant. For the designer evaluation, we recruited 16 participants who had experience designing social spaces and asked them to design a new subreddit with the help of social simulacra. What we find is that today, without social simulacra, the design practices for social computing systems are reactive. So participant 8's comment is particularly salient here, which says, basically all the rules are set in reaction to some dumpster fire. And our participants saw this as the reason why social simulacra could be really valuable, because it would offer them a sense of security if they could try different iterations of establishing norms before actually releasing these designs. We also find that simulacra offer concrete design insights to our participants. Among them are finding unexpected model citizen behaviors, like impromptu friend seeking to go sightseeing in a community for sharing fun events around Pittsburgh, and finding unexpected undesirable behaviors, like troll forums shifting the tone of a discussion community. So today, I presented social simulacra. But before I end, let me end this talk with one last takeaway point. And that has to do with what I call generative personas. I define generative personas as an approach for generating a breadth of possible human behaviors that might populate interactive systems to prototype and augment them. What we demonstrated today in social simulacra, in part, is the effectiveness of these generative personas. And I see an opportunity here. If we can master generative personas, I think it will open new doors that will enable new forms of interaction even beyond social simulacra that I presented today. So I will leave you with that and some social simulacra generated Q&A questions from our generative Brett Myers and Rob Miller as you think of your own. And thank you everyone for joining.
Questions? Please raise your hand. We'll run the mic to you.
Hi, June. Thank you for the great talk. This is Yujie from Stanford. I'm wondering if thought about like social media today also like comprise not only text but also like figures and even videos. With the same like generative like modeling principle behind, have you thought about like incorporating like generative figures or videos to help designers to augment their social media design?
Right. Thanks, Yujie. So that's a fantastic question. So one thing I would say is social simulacra is an approach. So today we focus on text, but really the idea here is to use these kind of generative models that were trained on broad data to do these kind of prototypings. For, let's say, so I'll go a little bit beyond social simulacra to answer your question. If you want to prototype, let's say, a space like Instagram, right? It's mostly photos. You can actually train not just large language models, but other types of generative models. So you can imagine, for instance, creating alt text using GPT-3 for, let's say, different images, and using that alt text to feed into DALL-E, which is an image generator, that would take a text prompt, let's say this is an image of a cat, and turn that into a photo of a cat or something like that. So that's the way we're viewing how simulacra would grow beyond the text space. But that's a great question. Thank you.
Yes, one last question.
Hi, great talk. Akar Gupta, Reality Labs Research Meta. So the utility here to the designer is when they see these different sort of behaviors, right? And in your case, what you tested was sort of a Turing test, where whether they can distinguish, right?
Yep.
Do you think that you could sort of generate response? So the designer cannot possibly look at thousands of potential behavioral sort of content that's generated, right?
Yep.
So can you generate sort of, let's say, 12 distinct responses? And maybe your generative persona thing is sort of the answer to that. But yeah, I'm just wondering if right now the system can generate sort of 12 responses for the designer to,
Right.
which are distinct enough, like one advertiser, one troll, one useful, one non-useful.
Absolutely. Yeah, that's a fantastic question. So so that I'd say is what if the what if feature of this tool is really allowing you to do. So what if can take basically user specifications. So when social simulacra is used just to generate a bunch of text, it will do the job of bringing in different diverse perspective and so forth. But what the user can also do is specify. I don't want to see tens of thousands of people of diverse personas, but I want to see, let's say, what a troll might do in this context, or what a pro-social model citizen might do in this context. What if lets you basically input that as a part of the social simulacra's input and generate very distinct and specific behavior on top of it. So that way, obviously, you don't have to filter through tens of thousands of comments to find some of the exemplary behaviors that you really need in these communities.
All right, let's thank June again. Our next talk is Ganzilla, user-driven direction discovery in generative adversarial networks, presented by Noyan Evriken.
All right, cool. Can you hear me? Right, cool. Hello, everyone. My name is Noyan. I'm from UCLA ACI Research of Professor Anthony Chen. Today, I'm going to talk about Ganzilla, a tool that allows users to discover editing directions in generative adversarial networks. Generative adversarial networks, GANs for short, showed compelling results in various domains, including stylization, scene creation, and improving the quality of scientific data. Unfortunately, GAN models remain a black box to end users with little transparency about what a model is capable of generating. To give you some background information, I will talk about what a direction is in generative adversarial networks. The way GANs work is GANs accept a random vector to generate data. Here, the vector Z generates a male human face. The editing direction in GANs, what we're trying to discover, is another vector called D. When the direction vector is added to the original vector Z, the GAN generates a semantically meaningful edited image. In this example, the direction D adds sunglasses to human faces, and lambda controls the strength of that edit. Typically, directions have been discovered with algorithm-driven approaches. Some of these approaches need a lot of labeled data to discover directions, which is called supervised direction discovery. Supervised direction discovery is really costly because you need a lot of labeled data. There are also some methods that discover these directions without data, which is called unsupervised direction discovery. However, unsupervised direction discovery lacks the expressiveness of supervised approaches. And recently, which is more related to our case, direction discovery has also been possible by enabling users to interact with GANs. Here on the left, you see interacting with GANs through text prompts and through segmentation masks. In order to enable users, we leveraged a classic approach called scatter-gather. This paper was first proposed in 1992, so it's technically older than me. The idea is used to browse large number of document collections. So basically, you can cluster the documents into broad main categories. You can see it at the very top. And then the user can gather the clusters of interest to recluster them again. And as you can see, the clusters become more refined and specific with each iteration. Today I'm going to present Ganzilla, a user-driven tool that empowers a user with the classic scatter-gather technique to iteratively discover directions. I will go with a specific case example and show how the tool works. To find a direction, user highlights, to find a direction, user highlights a couple of images based on the direction that they try to discover. Let's assume that the user is trying to find a happy face. After the user is done with highlighting, discovered directions can be found at the gallery. The images at the gallery are clustered and can be seen at the scatter-gather area on the left. Clustering is done using the resulting images, not the latent vectors, so that the clusters are semantically meaningful. Users can change the number of clusters from top and get more images if they're not happy with the current variety. Users can also click on clusters to see their contents. So in this example, I'm going to click on 2 clusters, and you will see the union of those at the top right. Users can scatter the highlighted clusters. So I'm scattering those 2 clusters. Scattering lets users focus on the selected clusters and sample more directions from those regions. Essentially, it lets them focus on a certain subspace of the latent space. And as I explained, with more iterations of scatter and gather, the clusters become less varied and more specific. Users can go back or forward in the scatter-gather tree. And after some iterations of scatter-gathers, the user can click on a direction from the gallery and test the direction in the test area. And they can change the strength of the direction to gain more insight. So if you increase or decrease the weight of the direction, you can clearly see what the direction is doing. And you can save a direction, which will then appear at the bookmarks area. And users can go back to any bookmark direction for future direction discovery. To validate Ganzilla, we recruited 12 participants from UCLA and asked them to use Ganzilla in 2 tasks, open-ended and close-ended tasks. I'll first start with the close-ended tasks. Both tasks consisted of 3 trials. So in the close-ended tasks, we asked participants to find specific target directions that we found before the experiments. These target images were shown to the participants, and they were tasked to find the same specific direction. For example, you can see at the very top, the first direction, it kind of opens the mouth a little bit more. So the tasks were intentionally specific to show that the Ganzilla can search for a desired direction. For the open-ended tasks, we provided the participants with a set of images and a high-level editing goals. So we gave them the first column, and then we asked them to make this face older, happier, and more surprised. And the other columns were essentially what the participants found using Ganzilla. The goals were intentionally open-ended so that the participants had to come up with specific edits based on their own interpretation of the goal. So for example, for the surprise case, some participants focused on the eyebrows, some of them focused on the mouth. It depended on what their interpretation was. Now I want to show some qualitative results. The first column is the original image, and the last column is the target image. And everything is between, found by participants. I randomly sampled them. And as you can see, participants use Ganzilla to find a direction that is similar to the target one. And I'm also going to share some quantitative results in a bit. And here are the results for the open-ended results. Since the tasks were vague, there is a higher variation between the directions, especially in the surprise case. It's really obvious. The open-ended tasks show that the Ganzilla can find a high variety of directions, which is another claim of us. And next, I want to talk about some quantitative results. We also validated Ganzilla with some quantitative analysis. Specifically, we ran 2 analyses for the close-ended tasks. In the first analysis, we sampled 1,000 random directions to create 1,000 edited images. And then we ranked the participants' edited images among these 1,000 images in terms of similarity to the target image. In 33 out of 36 tasks, the participants' edited images were ranked top 5. It is 36 because we had 12 participants and 3 tasks, 3 trials for the close-ended tasks. This basically means that participants were able to find a really high-quality direction, and they were top 5 among 1,000 in most of the cases. In the second analysis, we compared the participants' generated image, the edited image, to the target image by extracting features from another deep learning model that we didn't use. We then calculate the cosine similarity between the extracted features. You can see that number in the user-generated row. Essentially, the higher the number is, it means the generated images were more similar to the target image. To put those numbers at the bottom row into context, we ran the same analysis between the reference and target images. And as you can see, the user-generated images were more similar to the target image than the reference images, which shows that participants were able to get closer to the target. Next, I want to share some quantitative results for the open-ended tasks. We ran 2 analyses. First, we analyzed the user-generated images with a face analyzing tool called DeepFace. We use DeepFace to extract age and emotion predictions. We saw that on average, the age increased by 10 for the task of old, which basically means that the participants were able to generate older images. For confidence, for happy and surprised, the confidence values increased by 45.1 and 56.7%. Essentially, it means that the resulting images were happier and more surprised according to this deep learning model called DeepFace. In the second analysis, we used the CLIP model from OpenAI. For those of you who don't know what CLIP is, CLIP model can essentially map text and image into the same latent space. So it is ideal to check if a text prompt is similar to an image. We extracted the text and image embeddings of the open-ended tasks and calculated the cosine similarity. You can see it on the user-generated row. Once again, the higher the number is, it means that it's more similar. In order to put those numbers into some context, we also sampled 1,000 random directions and chose the top 10 using the CLIP embedding. So it's a very similar analysis that I showed before. As you can see, the user-generated directions perform better than the average of top 10 directions, which once again shows that participants were able to find directions similar to the text prompt. In conclusion, Ganzilla belongs to the following solution space. It is model agnostic, meaning it can work with any GAN model. It does not require any data or retraining. Instead, it leverages human intuition and finds directions with a user-driven approach. While Ganzilla finds directions, we did not design it to challenge algorithm-driven approaches. Instead, it can build on top of them. For limitations, directions discovered by Ganzilla can be improved through disentanglement, which is an open problem in GANs. We also realized the users can be guided more, since in certain cases, they felt stuck and they didn't quite really know what to scatter or gather. We also want to improve scatter-gather with more engagement, because also, in our experience, the users did not use scatter-gather as many times as we envisioned. It was mostly around 2 or 3 times. And finally, since Ganzilla is complementary to other algorithm-driven approaches, we also want to integrate those algorithm-driven approaches into our tool so that the starting directions are more semantically meaningful. Thank you very much. Now I will be accepting questions. Thank you.
Questions, please raise your hand if you have one, and I will run the mic to you.
Hi, thanks for the great talk. So your work is basically based on the GAN. So have you ever think about using like the stable diffusion, like DALI2, and then since we saw some results that they can do similar stuff, so any thoughts on this point?
There's actually similar work called StyleClip, which essentially takes a text prompt and discovers directions using that text prompt. My only concern with text prompts in this space is you can only explain so much with text. Even in certain cases, you can say a guy with open mouth and raised eyebrows, and you can go into details, but there are certain directions that are really hard to explain with words. And it's really, so the way I see it is you can communicate more information through images than text. So that's why we kind of stuck with just images and not really went through the text. But it's also possible, yeah. That's also an ongoing research area.
Hi, wonderful talk. I really love GAN work. I was wondering, could you elaborate on if it works on different types of GANs? So one's trained maybe on like just objects, things
Yeah.
beyond faces?
Yeah, so that's a great question. The reason that we stuck with faces was humans are really good at reading faces. Like once you look at them, you can immediately tell they're surprised or happy. So there's a wide variety of directions that you can discover. As I said, this approach is model agnostic, so it should work on any other model. But for example, when I tested this on, let's say, a GAN model that generates cat faces, it was really hard to come up with tasks or trials because it wasn't as seamless as analyzing human faces. So it should work with any other model, but we stuck with the human faces because of that reason. Yeah, thank you.
All right, let's thank Noyan again. This next talk is WeTune, a communication support system between writers and artists in collaborative WebToon sketch revision. And we have Hyung-Hwan Ko presenting it.
So hi everyone, my name is Hyung-Gun, and I'm here to present our work, WeTune, a communication support system for Webtoon authors. So Webtoon is a combined word for web and cartoon, so simply it's a cartoon and comics published on the web. These days, many people watch these using mobile devices like cell phone. Usually, a new episode is released on a weekly-based schedule. With increased popularity of webtoons, there are many collaborations between the writers and artists. Specifically, when the writers describe a scene with a detailed textual description, then the artist converts this into an image. As written here, if you look at the image over here, a young woman is wearing a white cap and a white mask and slamming her fist down on the desk. However, the communication between the writers and artists is very difficult since it's based only on text. As you know, there is no one-to-one mapping from an image to a text. For example, here, the angry is a kind of subjective word so there can be many different types of angry faces, and there can be drawn with many different types of styles. So this becomes a huge bottleneck in producing webtoons, since it takes a lot of time in editing images. For example, as you can see here, the writer wants to modify a specific part of the face. Sometimes they have to go through many iterations, so it results in a delay in production. So a direct editing of image is not possible, since writers often have difficulties in precisely articulating their feedback on sketches because of their lack of proficiency in drawing. So to deeply understand how webtoons are made in practice, we ran a formative study with professional webtoon authors. They had experience in collaborative webtoon creating from 1 to 10 years. Overall, we identified 6 stages in total, but we are going to introduce 3 of them that are most relevant and important to our work. First, the webtoon authors make rough sketch images as a draft. And then the images are refined iteratively and become clean sketch images. Finally, the webtoon authors finish up the details like coloring, shading, and adding word balloons. So here we realized that the rough sketch stage is the right one to fix images, especially because it requires much more time when it passes this stage. For example, if we need to edit a colored image, all 3 stages need to be done once again after editing it. However, if a rough sketch image is edited, we only need to redraw a rough sketch image one more time. So after identifying the most important stage, we set our design objectives on how to help the writers convey their revision intention more efficiently and effectively. So the first one is to support the writers in retrieving the desired reference images, and the second one is to support the writers in expressing their revision intention. To support these design objectives, we found some state-of-the-art deep learning models like StyleGAN and StyleMapGAN, and we constructed WebToon images for training these models. To this end, we made an image corpus of 47,233 WebToon images from 441 WebToons. So we will skip this detailed explanation, although we put a lot of effort and time in constructing this data set. So with this data set, we trained StyleGAN and StyleMapGAN to generate and synthesize images. So these are adapted to augment the writer's capability to convey their revision intention in editing WebToon images. So this is our system, WeTune. Here, first the user can upload any kind of image that is drawn by the artist. They can resize and align the image with simple clicks. To make a reference image for synthesizing, users can choose attributes and change the details of chosen images. Also, users can change facial expressions or the orientation of faces. Since we could not give names of each label because of a technical issue, we put an image label instead so that they can refer to it. Finally, users can synthesize the image onto the source image that is drawn by the artist. They can add additional layers as much as they want and can move brushes to fit their desired region for editing. So you can move the brush region like this, and after that you click the red arrow, you can synthesize the image. So using our system, the writer can send a comprehensive comment, including brush region, a text description, and a synthesized image, which means where and what and how, respectively, to add an image by reflecting the writer's intention more clearly. Artists can refer to this comprehensive comment and edit the image more effectively. We performed the user study with 12 pairs of professional WebToon authors to understand that our systems can facilitate the communications between them in sketch revision. And it was proven that our system can convey intentions more intuitively and effectively from both sides. Also, there are some qualitative findings we want to share. Although previous papers said it is important to focus on the quality of the generated images, WebToon authors highlighted the quality was not the primary issue in communication. It was more important to reflect their intention, so the clarity was more important. Also, some WebToon authors said that it can circumvent around the plagiarism issue. Although it is very common to use reference images, the WebToon authors did not prefer to use them to prevent plagiarism issue. They said AI-generated images do not seem like an existing ones, so it can be used for synthesizing some part of generated images without any concerns. We have some limitations, although. For example, we only cover the faces of WebToon characters, so we hope that we can generalize this into whole body of WebToon characters. So this is the end of my presentation, and thank you very much for the attention. Please let me know if you have any questions. Thank you.
Questions, please raise your hand and I will run the mic to you. All right, in the back.
wondering, you said you would like potentially be expanding to more body parts or more genres, but do you think you could also make this work for like environments and backgrounds and maybe even like objects in the scene as well?
Thanks for the great question. And I think it is really possible because the capability of GAN is really exciting and very powerful. So I think the most important thing is to gather the data set, because we put a lot of time and effort in gathering all the face data sets. So if you can, for example, if you want to make some kind of nature, you have to collect like 1,000 or 10,000 like images. So if that is possible, I think that can be possible.
Awesome. Other questions? If not, I have one, which was, you mentioned in the beginning there are many like stages in the WebToon generation process. Why did you specifically focus on the sketch one?
So if you pass through the stage, there can be more work added afterwards. So if you refine the sketches and added the colors, everything, the artists have to do more works. For example, if you have to edit a colored image, that need to be edited in the previous stage as well. So for example, you have to draw the draft and then need to be edited like sketch, refined afterwards, and then the coloring has to be added like so. There need to be more and more work. So it is more efficient to finish up the making the consensus at the front stage.
Thank you. Last call for questions? All right, then let's thank Hyung Kwang again.
Thank you.
So the next paper in the session, the second to last one, is BO as Assistant, using Bayesian optimization for asynchronously generating design suggestions, and will be presented by Yuki Koyama.
Okay, so thank you for introduction. So hi everyone, I'm Yuki Koyama from UIST, Japan. So in this talk, I'd like to present a new human-AI collaboration technique. So especially we use Bayesian optimization, or BO in short, to support designers by generating design suggestions. Okay, so let me begin with the background. So we can find parametric design scenarios almost everywhere in digital content creation. So for example, photo color enhancement involves many parameters such as brightness or contrast. Also, machine learning-based content generation often involves parameter tweaking to search for the best latent code. Procedural modeling and procedural material design are widely used in film and game production, where many unintuitive parameters need to be adjusted. Okay, so from the mathematical viewpoint, this task can be considered as a mathematical optimization problem, where the designer manually performs the search for the optimal parameter values. So this problem is challenging from computational viewpoint, since its objective function is defined by human preference. So human-in-the-loop optimization is a promising approach for this kind of problems. So in this framework, the system provides candidate designs and asks the human to evaluate the design candidates. So to implement such a framework, Bayesian optimization, or BO in short, is one of the most attractive choices. So Bayesian optimization uses an intelligent sampling strategy, and thanks to this intelligence, BO can find a good solution within only a small number of iterations. And previous work has explored various applications, including photo color enhancement and 3D computer graphics, and even non-visual content generation, such as melody. And also in this UIST, in the afternoon session today, my co-author will present a real-world application of lighting design for photographers. Like this, previous work has successfully used human-in-the-loop Bayesian optimization to enable efficient search for optimal parameters. However, it has a problem that motivates our work. So in human-in-the-loop BO systems, the designer cannot freely explore the design space based on their intuition or based on their domain knowledge. Because what the designer can do is just evaluate the provided design candidates. So unfortunately, this may reduce the sense of agency or, and creativity, which is undesirable. So here is our motivation. So the question is, can we benefit from BO's intelligent sampling while providing the designer with complete freedom in the workflow? So in this paper, we introduce a new framework called BO as Assistant. So in this framework, the designer can freely explore the design space using sliders as usual. And instead of asking questions, BO just observes the slider manipulation behavior to learn the designer's preference. Then it asynchronously provides suggestions generated by BO's intelligent sampling strategy. Note that there is no explicit loop and BO requires no explicit inputs. Instead, BO just tries to assist the designer without disturbing. So this is a screen capture of our working prototype system for procedural modeling application. The designer manipulates the sliders to explore the design space, and the left one is the current design, so the design preview, and the other three are the suggestions generated by observing the slider manipulation and using BO's intelligent sampling strategy. The designer can use the suggestions anytime. So there is a slider called a blending slider for each suggestion, and it allows linear blending between the current design and the suggested, the selected suggestion. So in this way, BO assists the designer without disturbing. Okay, so now let me explain the technical part. So first, I'd like to explain an existing technique called preferential Bayesian optimization, which we use in our framework. So first of all, Bayesian optimization is a global black box optimization algorithm which can find optimal solutions within only a small number of iterations. So this property is enabled by its intelligent sampling strategy, where it generates new samples from unexplored and high expectation regions. And due to its sample efficiency, BO is often used for hyperparameter tuning in deep learning. So in this work, we use preferential Bayesian optimization, or PBO in short, which is a variant of BO. So unlike BO, PBO runs with relative preference data rather than absolute scores. So it is often suitable for human-in-the-loop settings. In this work, we consider to extract such relative preference data implicitly from slider manipulation. Okay, now I'd like to explain our technique to extract preferential data. So here, please assume that the designer tries to enhance a photograph by manipulating sliders. So let's have a closer look at how a slider is manipulated. So suppose that the designer currently considers the photograph to be too dark, and wants to manipulate the brightness slider. The designer presses the slider knob and starts moving it to the right to make it brighter. During the movement, the designer checks the appearance of the photo continuously, And at this moment, it is still too dark, so the designer continues the movement to the right. And at some point, the designer notices that the photograph looks too bright, so meaning that the slider knob needs to go back. Then the designer moves it to the left. And once the photograph looks adequate, then the designer stops the movement and then releases the slider knob. So this represents a typical slider manipulation behavior. So of course, the number of these back and forth behaviors can be different, but anyway, we can observe that first, the last point is likely to be desirable, and second, the turning points are likely to be undesirable because such directional change is likely to be intentional. In this work, we put an assumption that the last point is always preferred over the turning points. So, and we propose extracting preferential data using this assumption. So that's the key idea of this paper. Okay, so using the extracted data, we can calculate the Bayesian optimization process, a preferential Bayesian optimization process. So this slide shows how the internal models are updated and how the suggestions are generated in a two-slider scenario. Please refer to the paper if you are interested in this part, but the key point here is that the suggestions are sampled from regions with high estimated preference and high uncertainty, which is the key to generate useful suggestions. Okay, so let me show some working demonstrations. So in this demo video, we show a photo color enhancement application with 12 sliders. So this video shows the interaction. So note that the initial suggestions are more random, but they become more reasonable as the process progresses. So this indicates that the system learns the preference progressively. And this demo is about procedural material design for 3D computer graphics. So in this case, the user wants to obtain a rusted metal material with peeled painting. And so procedural material design involves many unintuitive parameters that correlate with each other. So in general, this task is difficult even for experts. So providing suggestions helps the designer a lot in such cases. And we can see that BO successfully provides good suggestions, useful suggestions in this case. Okay, so our framework learns the user's preference from the slider manipulation behavior. So if the user have different goals in mind, it is expected that the suggestions are also adapt to the goal. And this shows how it works in such cases. So we can see that different preferences are learned, and so different suggestions are provided adequately in these two cases. Okay, so in summary, we propose using Bayesian optimization as an assistant of a designer, unlike previous human-in-the-loop systems where the system takes the initiative. To enable this, we propose a new technique to generate suggestions using Bayesian optimization just by observing slider manipulation. And our framework is general and applicable to various design domains as demonstrated. Okay, that's it. Thank you for listening, and I'm happy to answer questions. Thank you.
Raise your hand for questions, and I will run the mic to you. All right, we have many questions. I'll get to you all.
Hey, Yuki. Cash from Reality Labs. Great work, thanks for this. I was thinking about one thing. So in your system, the design is playing with the sliders, and your system provides suggestions in the form of final designs. How do you think that compares with providing suggestions for the parameters itself, that the designer can then further explore?
Sorry.
So instead of providing final design suggestions, right now you're providing like layouts or designs, right? Instead of providing suggestions for those sliders itself, for different parameters that are promising. You know what I mean?
So your question is how about providing parameters instead of designs?
Design process, if you provided suggestions for the parameters itself, that the designers could then independently explore.
Sorry, can you elaborate the question?
Okay, so like in that diagram up there, right? So on the left side, the designer's playing with those 4 sliders.
Yes.
Right, and they move that, and as they do that, those suggestions are generated on the right side. So they get 3 suggestions.
Yeah.
But instead, they could even get suggestions for the slider values itself, right? Saying maybe the position 10 is a promising value versus position 80.
So you mean suggesting the slider positions directly in I see. So yeah, that's possible. That's maybe provide different user experience and different usefulness. So yeah, that's a very interesting. That may be interesting future work. Yeah, that's possible, technically possible, and yeah, that's nice idea. Thank you.
Hello. Hi. Thank you for the good talk.
Thank you.
For thought-provoking ideas. One question I have is about those 3 suggestions. How did you choose those 3?
Oh, I see.
If you had, and would you think that the results would be different if you chose 9 or if you chose 20 suggestions?
So yeah, we choose the number 3. So the number is not justified well because I just choose 3 because it seems useful.
Adjusting one parameter alone.
So the question is the user manipulates one slider. So how about other parameters? Yeah, correlation. So yeah, that's a little difficult to explain, but so basically, if the user manipulates only one slider and not manipulating the other sliders, then the data is very locally located in the whole space. Then in that case, so we use Gaussian process inside the algorithm, and the Gaussian process covariance parameters are learned so that the covariance matrix adapt to the data distribution. So yeah, so that's yeah. Maybe you can talk after the session. Sorry.
I think we have time for one more question. I saw a few more hands. Sorry if I don't get to you. Talk to the author after.
Thank you very much. Very good talk. I'm Zhongyi from Tokyo. And I would like to ask about how the method to select the suggestion design. I heard you mention that that's basically based on uncertainty, right?
Yeah.
I'm wondering whether it's possible to consider something like diversity. For example, is it possible for some cases that all the suggestions are quite similar because they are all quite uncertain? But I think for user, it's more important to see a lot of like different kinds of design.
I see. Thank you for the question. So yeah, currently we the diversity of the suggestions are controlled by the balance between exploration and exploitation properties of BO. And currently we just put a hyperparameter that define the balance. So we just use fixed value. But if we choose the hyperparameter value adaptively, then we can technically provide a different diversity. So we can control the diversity of the suggestions. So, but we don't know how to control the hyperparameter in a useful way in the realistic scenarios. So that's maybe a good feature work, I think. Thank you.
All right, let's thank Yuki again.
Thank you very much.
The final paper in this session is Chatbots Facilitating Consensus Building and Asynchronous Co-Design, presented by Julie Shin.
Okay, welcome everyone. I'm Jun from Aalto University, and I'm happy to present our work, Chatbots Facilitating Consensus Building in Asynchronous Co-Design. In this talk, I'll present how conversational agents like chatbots can assist a group of people to reach consensus, even without having them to have a live conversation among group members. We investigated this subject in the context of co-design, where consensus building is an essential group activity. Co-design is a collaborative design method that actively involves diverse stakeholders of end product throughout multiple design processes. So for instance, if this co-design project is about designing course activities, this would involve teachers, students, teaching assistants, or even course administrators to discuss their ideas and make decisions together. For this, trained facilitators assist them to collaborate regardless of the differences between their hierarchy. So in short, co-design is about sharing design accountability among stakeholders and making them satisfied that they were in part of the design process. Throughout the co-design process, stakeholders identify their needs, which are often conflicts with each other and also impossible to satisfy all of them. In such case, it is important that stakeholders reach consensus on how to resolve conflicts. By discussing potential solutions and making decisions together, everyone should be able to agree on a solution, even if it does not fully satisfy individual members. So in the other words, consensus building is about increasing everyone's willingness to commit to group decisions, even if they are not fully satisfied with it. However, consensus building is a challenging process. It requires high effort from facilitators to intervene and guide the discussion, adapting to individuals' behaviors. And also group discussion often constrains everyone to ideate at the same pace and also for a limited duration. Without having enough time and also getting the facilitations to individuals, consensus building can fail, or even worse, everyone can believe that they reached consensus, but when they are actually thinking something different from each other. So for this, we investigated how conversational agents can be designed to facilitate consensus building asynchronously, which I mean by without needing a live conversation among group members. So compared to human facilitators, chatbots can engage with individual group members to help them to ideate at their own pace. It could collect and present the other's thoughts and guide structured ideation for individuals to build on each other's viewpoints. Previous studies have shown to use chatbots for facilitating live group discussion, such as enabling equal turn-taking or summarizing themes throughout the group discussion. But how to or whether chatbot can actually engage with individuals and also during asynchronous consensus building is still an open question. So accordingly, we ask whether chatbots can increase group members' willingness to commit to group decisions, even without having a live conversation between them, and also whether it can also make them willing to commit to group decisions that conflicts with their personal opinions. So we designed a rule-based chatbot based on a consensus building guidelines found from literatures. And the key idea is that the consensus building process should be perceived as fair, giving all members the same chance to voice their own ideas and perceive mutual effort throughout the process. To achieve this, our chatbot asks people for an idea to resolve conflicting needs and make them aware of the other's ideas and suggest them to consider opposite viewpoints. This is performed in 5 steps conversation. First, our chatbot contextualizes the conflicts and consensus building by introducing the groups in conflict and their needs. Then the chatbot asks individuals to propose an idea for satisfying both groups. If they think it is impossible to satisfy both groups and respond it would be impossible, the chatbot will ask whether voting would be the second best solution, and also ask why the people would think that this would be a fair approach in this case. Then the chatbot asks people to evaluate their own ideas, considering how helpful they would be for satisfying both groups' needs. And to make people aware of the other's mutual effort, the chatbot shows the other's ideas in a quote that are both similar or opposite to the people's initial ideas. Especially for the opposite ideas, the chatbot asks people to try advocating the other's viewpoints. And lastly, the chatbot displays all the ideas that individuals have encountered during the conversation and asks them to select the one that they think is most fair to both groups in conflicts. To evaluate our chatbots, we staged 12 university students in an asynchronous co-design project. We made them only interact with our chatbot individually and informed that the other students and teachers were also ideating through the chatbot. To set a similar consensus building situation among participants, in the first day, we collected their needs and prepared conflicting needs for individuals. Then, in the second day, we compared participants' willingness to commit to group decisions just before and after they interacted with our chatbot. And in the last day, we presented group decisions that both conflicts or aligned with their original ideas. So in this presentation, I will share individuals' perception of their behaviors, and for more details, please refer to our paper. The survey before and after the interaction showed that the chatbot increased the participants' willingness to commit to group decisions, even if they did not have a live conversation with the others. On the graph, the darker blue bars represent their responses after interacting with the chatbot, and toward the right means that they had more positive responses. So for instance, it shows that the participants were more willing to empathize with the other's suggestions and consider them as potential solutions. And the interview revealed that it made the participants believe that the chatbot facilitated fair consensus building with everyone, which made them increase their willingness to commit to group decisions at the end. On the survey on the aligned and conflicting group decisions showed that participants were also willing to commit to the group decisions that conflicted with their personal opinions. The survey showed that they did not want to take the conflicting group decisions. However, they were still willing to commit to them at the end. They reported that they could sense everyone's mutual effort through the chatbot. Hence, they believed that the group decisions were made by giving a fair chance to every group members. So based on this result, we conclude that chatbots can be a facilitator that assists consensus building asynchronously. From our observation, I would like to share a few design implications for designing a chatbot that can facilitate consensus building. So first, chatbot should provide instructions for individuals to better promote their own thoughts. So what people should do during this consensus building is not just reporting their ideas to the chatbot, but rather voicing their thoughts to the other group members. By talking with chatbots, group members should be able to believe that the others will also understand and consider their own ideas. And second, chatbots should present common ideas among the group members at the beginning of the conversations to facilitate effective idea generation. In the current interaction, the chatbot showed the other members similar ideas, mainly to highlight mutual effort. In contrast, it appeared that common ideas or similar ideas could also be used as inspirational materials to all the group members, so they can effectively explore potential solution spaces and make progress as a group. Lastly, chatbots should facilitate opinion exchange even after group decisions are made. Despite increased willingness to commit to group decisions, the participants wondered about the other's thoughts on the group decisions at the end. Especially for the conflicting group decisions, they wanted to know more about why the others have supported the opposite ideas, even if they already saw such opinions throughout the chatbot interaction. We believe making this explicit could help them strengthen their consensus. So in summary, with this study, we contribute to understanding AI-supported collaborative ideation between humans. We investigated Chatbot as the facilitators of asynchronous consensus building. We designed a conversational flow that employs the guidelines of consensus building. And finally, we conducted an empirical evaluation study to discuss design implications of such chatbots. Lastly, I would like to say that reduced social interaction between humans through conversational agents could also bring some more benefits. By enhancing anonymous ideation, chatbots could mitigate negative social interactions that would occur during the live discussion, such as group members blocking each other's idea exchange or negatively demotivating them to share more ideas. I believe further investigations on what conversational agents can bring to collaborative ideation between humans could introduce more effective ways of collaborating with each other. This is the end of my presentation, and thank you for your attention.
Questions? Yes.
Thanks for the great presentation. I'm Songjae from PostTech. So I was curious whether visual characters, visual presence, or voice of a chatbot could further improve your system.
Thanks for the good question. So I believe that there would be definitely affect this kind of interaction, because one of the things we noticed throughout this study is that interacting with the chatbot is really just different from reading a script from just an online survey or the other form of interaction, because users already perceive the chatbot not as a just artificial machine. They actually think they are interacting with ideation partners. So definitely giving them such kind of characteristic can help them to be more motivated to accept the other's opinions, or even more critically think about some differences between their ideas.
We have time for one more question.
Hi, I'm Jian from University of Calgary. So I have a question about in terms of asynchronous communication. So I'm just imagining in the future of work space where you have two different engineering teams from globally in different time zones. How can you facilitate consensus buildings with this kind of engineering decisions when it comes to remote working?
Okay. So already in this asynchronous setting, what we expected is that actually such kind of scenario where everyone is interacting with this, through this conversational agent from different time or different places. I believe, although in our study we were mainly focused on how this chatbot can project the other's presence or mutual effort, so they can have better understanding of the other's viewpoints. But I believe that also that can be similar in the engineering scenario, where every member needs to understand what is the rationale that this other group is suggesting these different ideas. So I believe this chatbot similar approach can be also used to have them to more focus on not just the differences between the teams, but the difference between the ideas and rationales behind them.
All right, let's thank June again. So that was the last paper in the session. If you have additional questions for the authors, I encourage you to come up. We'll hang around here. Otherwise, thank you for attending the generative design session and enjoy your coffee break.
Oh, for sure. Yeah, no, it's,
I'll keep that in mind.
I will kick you off if necessary, but I don't think it will come to that. Excuse me, like I said, lung scraped clean. But it's mostly just so that you're aware of your time. I don't know, because like not everybody has a timer on their screen when they talk. So.
That's true. Or am I conscious of it, I guess?
Yeah.
It's easy to overlook.
Yeah, did you test?
Nope, not yet.
Okay, I recommend you do that.
Sure thing.
Especially if you have sound, it's a good idea to do it as soon as possible.
Luckily, there is no sound.
Great. I watched one talk in here. I watched only the first talk in the last session.
Yep.
But it seemed like the mics had some issues. Did that clear up towards the end of the session or no?
I wasn't watching the one in here.
You weren't.
No.
Okay.
Okay.
between the two talks. I'll also have a timer on
Oh,
my
perfect.
computer, so hopefully you can see that.
Yes.
If you Google timer, it will give you a timer, and then you hit the full screen, and it actually is like.
I am looking for HMD. HMD.
HDMI is right in
Oh,
here.
this one.
Yep.
Okay, perfect.
It's got a very Google typeface to it.
I have to say though, like, I think that they might have taken branding a little too far in some cases. Like when I open, I have like a folder of Google apps on my phone or whatever, and when I look at all the apps in the Google folder, I'm like, I can't just like glance and see what's what because they're all so identically, and I'm just like.
Curvy nature to it.
And the
color
like
scheme.
four colors and like,
Yeah.
you know, the line weights are all very like it's a weird.
Okay, sounds good. Yeah.
Do you have any sound?
No.
Okay.
Yeah, I guess that's where like Microsoft Office is nice because you have different colors for Word, PowerPoint. So there are two more people.
I hope so.
Is outside the room now. Another one.
Okay.
Oh, here we go.
How's it going? Good. Please try your setup. I was just saying to the other two that I have a timer that I'll have on. And I'll probably call you up to start about the previous presenters finishes. I also won't read the entire author list.
Oh, that's fine.
Because I figured you're going to do that. So.
Yeah, that's fine. That's fine.
Okay, that sounds like.
Hi, can I check? Nice. It's nice. Sorry, I just want to check if it is worth.
So I'll have a timer for you.
Okay.
For your talk. And I'll ask you to start setting up.
Okay.
While we answer questions with the previous person,
Mhm.
so that we stay on time.
Okay.
But yeah, this will be fun. Are you excited?
Yeah, kind of nervous.
I thought it was so cool.
Thank you. Okay. I'll check it.
That's for me or that's for questions? For questions. So which one should I use? Should I just talk up there? That's fine.
We need to check.
ね。ちょっと。あ、华马。うん。環境設定。あ、これ。ディスプレイ。これ。ああ、ミラーリング。
これで再生してみて。
ああ、オッケーオッケー。
動画は？音はあるんだっけ？
あ、音ないです。うん。よかったです。
half minutes left. Just about.
I am going to start right on time.
Okay.
So that we
And
get finished on time. Yeah, I'll be
sounds
talking
good.
to them.
I was hoping to hold it, so is it all right if I take it out? Okay.
Oh man, are you going to like TED Talk? Like walk
That'd be
around
nice.
stage
I feel more comfortable that way.
Cool, super. Unsuspecting people will trickle in, so. Hi, everybody. I know that some people are still going to come in from the coffee break, but we're going to go ahead and get started. My name is Valkyrie Savage from the University of Copenhagen, and I'm going to be chairing the session about 3D printing. We have all kinds of weird and awesome papers that we're going to sit through for the next hour. Also, as a reminder, remote people, you can ask questions on Discord. I have a way to monitor that. And the rest of you that are here, if you raise your hands, the SDs can bring you a microphone. So our first talk, we're going to have Eamon Littler telling us about multicolor 3D printing on the cheap.
Thank you. All right, let's get started. Hi everyone, my name is Eamon Littler and I'm from Dartmouth College, and I'll be presenting our paper on automated filament inking for multicolor FFF 3D printing. Now, fused filament fabrication 3D printers, such as these, have seen a surge of popularity in the sphere of DIY enthusiasts and the hobbyist space. And this is thanks to the advent of low-cost 3D printers, some being priced even below $200. You could get prime shipping on those too. They could produce really complex geometries, as you can see here, just a spread of different things that you couldn't imagine making on your own, let's say, 10, 15 years ago. 3D printing's come a long way. But something that 3D printing lacks is in color. You can see here, after a while, though you have complex geometries, the models start looking the same. That's not to say that there's no complexity to it, but color is something that's very desirable. And we could see that in this example right here. Without being told, you could immediately see in the kidney model, for example, the different parts of a kidney. I have no clue what the parts of a kidney are, but I can at the very least distinguish between their different parts. So this would be immensely useful in an educational environment where educators could use multicolor 3D printing as a tool for learning. And this process is really helpful for designers as well, getting as close to their final designs as possible without having to ship out their full color 3D print to some industrial company that would print and take extra time, let's say weeks, potentially. So this would be really desirable to have kind of in-house. So in the commercial world, we have options such as these. They're kind of customized 3D printers, where on the left we have the E3D tool changer. It's a mechanism where you have multiple tool heads with, so you have 4 nozzles. These nozzles are loaded with different rolls of filament, and it's switching between each nozzle throughout the process of printing, thereby giving you 4 colors. On the right, we have a Prusa 3D printer that's equipped with a multicolor filament swapping mechanism called the MMU2. And this, in a similar way, unloads filament, loads in new filament for the switching process. But the problem is these solutions are very customized to each device. It's not something that translates very well if you're moving from one multicolor 3D printing technique to another. In this way, the paper Programmable Filament by Takashi et al. In UIST 2020 really brought multicolor 3D printing to the forefront of makers. It's something really amazing. It's a low cost, no cost in fact, solution that democratizes multicolor printing. And in this way, it's something that's in the hands of makers, which is amazing. And we wanted to kind of make progress in addressing some of the limitations that were found in this approach, such as in their approach, they would 3D print filament. And then after 3D printing filament with different sections of color, you would 3D print once more with that same filament to produce multiple color prints. It is a time-intensive process, potentially, depending on the number of colors that you work with, as well as being limited to the size of your 3D printer build plate for how much filament that you could print at once. So to address all those limitations, as well as maintain the low-cost approach for multicolor 3D printing, we propose a novel approach by inking the surface of filament. In this way, you have a single roll of filament that you're not interrupting whatsoever, you're just applying color on the surface. And in doing this, we have an automated process using an inking device that we created. And this process, there's no restrictions for the length of the filament. You don't modify your 3D printer. The inking device is completely detached from the 3D printer itself. It's also very fast, taking roughly 5 to 10 minutes for most common prints. Of course, the larger your print, the longer it'll take. So looking at a demo here, we have our inking device loaded with filament. We have 4 print markers that are engaged, and the coloring process begins. You can see the colors are applied on the surface. And then you have your inked filament that's then loaded into your 3D printer. Then you could print as you normally would to get your final print. Taking a closer look at the inking device, it is a completely 3D printed design. I'm seeing flashes, so let me know if it's not showing up. It only costs $50 in parts to make. This includes both the 3D printed components as well as the electronics. You could have up to 4 colors, although the design is something that you could adapt to support more. It's completely open source, and if you'd like, you could download the files from our GitHub repo, and if you have a FFF 3D printer, feel free to try it out. Taking a look at the electronics, we have an Arduino as the brains. It's all low cost, something that you might even have in your toolkit for basic electronics, stepper motor drivers, servo motor drivers, micro SD card reader, all the common stuff that you would find. Taking a look at our workflow, looks something like this. So our pipeline starts off by generating G-code. You then generate a simplified instruction set for your inking device. And from there, we would load this instruction set into our inking device, color the filament, and then 3D print. But something I'd like to stress is the fact that this is completely optional. Our pipeline is meant to be something that's unobtrusive to the process of multicolor 3D printing. If a user wanted to choose to print with a typical approach, they could just go from step 1 to 4, or they could have color as an option. Now that you've seen the hardware and some of the other parts of the process, let's imagine what the filament needs to look like. So on the right-hand side, we have conjoined cubes, one in cyan, the other in magenta. So what's the ideal filament that we're looking to produce? It might look something like a single strand with alternating sections of cyan and magenta. And this is what we do in our coloring process. We just alternate color sections. Taking a look at the pipeline that the user will see, they would start off by generating G-code. Now you might have, in a typical multicolor 3D print, a multi-part 3D model file that is then loaded into a slicer, such as Prusa slicer in this case. And those files are joined together automatically, and then you could generate your G-code. Additionally, this was an update that happened just less than 2 weeks ago. Prusa has a new tool for taking a single file, regular STL mesh, and then you could color the surface of the mesh to apply colors. This way you don't have to work on making multi-part 3D models. It's not relevant to the paper directly, but it's something that I found cool. So G-code is very long, tens of thousands of lines potentially, and it's not something that our poor little Arduino could process. It has memory limitations, so what we need to do is take the G-code file and make a simplified set of instructions. We call this an inking file. It's just a plain text file that looks something like this. So we have here, line by line, something that's human readable. And on the first line, we have an E parameter. The E parameter specifies the position at which color is started applying. So we start applying color at position 0, and then we specify which color to apply. So we have a CMYK color scheme here. So cyan is being applied. You could see that there are values 1 and 0, so it's a binary switch of engaged or disengaged. We then load this onto a micro SD card, and then we color our filament. So making the inking file is something that's very cumbersome by hand, so we created a web interface to automate this process. You could take your G-code file and then you could throw it into our web interface to automatically generate the inking file. We also have a customized way of making discrete color layers, similar to if you were to 3D print a name tag, let's say. A background might be white, the text might be black. Now, this is something that people would often print with, where they would stop the layers and then they would unload filament and load in filament of a different color. We made an experimental interface to allow users to work with this functionality. It's similar to Unity's color picker or Adobe Photoshop's gradient tool. But you have these sliders that represent the divisions of your color for your filament, and then you could add more divisions. You could move the sliders to change how much color you want to be applied. You could do this for as many colors as you want. You could specify the length of the filament, and then download your inking file. You might be wondering, what kind of colors can you reproduce? And it looks something like this. On the very top, we have prints with opaque filament. In the middle image here, we have translucent filament prints, as well as regular 3D prints. These are just tiles that I colored by hand after the fact, just to see if there's any difference between the filament, the ink filament, and the pigment that passes through a hot nozzle. There seems to be. In the case of the green filament, we could see that when it's 3D printed, there's a little bit of a discoloration. It looks more teal rather than the forest green that we expect. Here are some of our results. We have a dual print veggie boat on the left, and then we have 4 overlapping rings of 4 different colors, and both printed with translucent PLA. We also did an identical print, one using opaque filament on the left, and the other using translucent filament on the right. And you can see that there's a very visual difference between the two. The translucent filament, you can see the underlying layers, so that contributes to more contrast, whereas the opaque filament gives more of a flat look. Using the tool that I mentioned earlier, the experimental one for discrete layers, we also have these sample prints changing between magenta, yellow, cyan, and black. And going from left to right, we have an increase in the number of perimeters, as well as a little bit of color mixing on the print on the right-hand side. This approach is very economical. We have, traditionally, you could imagine if you want to print with 12 colors, you might need 12 spools of filament. This is an issue since it will be an upfront investment of $300. But using our approach, you could have the same 12 color varieties to work with just for $85 essentially. Filament also goes bad. It has a shelf life. It's something that could absorb moisture and become brittle. So that's a big issue, but we're also helping kind of reduce potential waste in that way. There are limitations for with the calibration. So you do need to have a precise printer. You do need to calibrate your E-steps to make sure that everything is tuned in. You need to know how many pulses on your stepper motor for the extruder equates to 1 millimeter filament extruded. Without that, you have prints that look like these, where the colors invert gradually throughout the print. So you have an alginated ocean and continents that are flooded, essentially. We also have an issue with directional color. So if you were to print with opaque filaments, then you could see color a lot more bright on one side. We try to apply as much color as possible, and we add a notch to the permanent marker to apply color to half the surface of the filament. But even then, with opaque filaments, we could see that there's a difference between the front side versus the back side. One side shows up a little stronger. As for future works, we're looking towards improving the color calibration, giving us access to more approaches such as dithering, or having internal and external layers where the color differs for subsurface scattering properties. That'll be an interesting field to work with. We also experimented just a little bit with mixing colors, as seen with the examples here. Opaque filament on the top left image, and translucent filament on the top right. Both prints were colored with red and green, and you have very different color results. So it's something that's really exciting potentially to explore. With that, I'd like to thank you for coming to my presentation.
All right, we have time for one very fast question, and I need the next presenter to come up and start setting up. Right there.
Koya from the University of Tokyo. It's actually a really clever idea. So my question is, did you consider using some functional inks for your marker?
Functional inks in what
For
way?
example, thermochromic ink or photochromic ink or conductive ink?
Right, so it's not something that we tried yet, although it's an idea that we had. It would be interesting to explore other materials such as conductive inks.
Yeah, I'm saying this because in general, it's really hard for us to have access to the filament with special material properties.
Right.
So it's going to be a really clever idea for the future.
Thank you. Yeah, it would be especially interesting. The only issue would be the potential carbonization in the nozzle. So if you could avoid that, then you're good to go.
Thank you so much. Let's thank Amit again. All right. Next up, we have Harinya Pongsanon, who's going to talk to us about edible QR codes.
Thank you. So, hello everyone. My name is Pranyapan Pongsanon from Osaka University, and this works recent research on 3D printing, on the food domains and food interactions. Maybe that difference from another work in these sessions. So, I would like to present the interior, the unobstructive eatable tags using food 3D printing. And this work is co-authored with the Yamato Miyatake, Daisuke Iwai, and Kosuke Sato. So our work is to explore the tags for applications with the less obstructive to the food experience. As you can see, within the normal conditions, you just see as the cookies here. But once you put the backlight on it, you could see the QR code that you might be used for some applications. For example, like as a marker to track and localize the positions of the food. Or step forward, like you can use to filter and separate the food ingredients that might have the same appearance on the outside, and so that you can make the pair of the drinks, and also after you are finished with the data, you can eat them out. Yes. And before we are going into the body of our works, I would like to start with the motivations of our food tag along with the little works in the decision. So as you might know, the tags have been used in several applications. For example, like to manipulate the robots for the cookings, or to use in the retail store to store the food information, like the price or food ingredients. The food tags are usually attached on the food package or directly to the food surface. And the tags are usually visible to the user, which might at some point reduce the deliciousness of the food, such that the tags are made with plastics and they are inedible and a little bit less sustainable. Peeling off the tags may also damage the food surface, which affects the eating experience. So previous work that tackles this kind of issue on the food tag, such as Qki or Meta Cookie, utilize the edible inks to print the tag directly on the surface of the food. Or maybe utilize some laser cutter to engrave the surface of the food so that it can be used as a tag. And as you know, the tag, to tackle this issue, they are tackle the edible issues. So the tag now edible, but they still appear on the surface and thus maybe reduce the eating experience. While for inedible tags, for applications, recent work such as the infrared tags and the air quartz utilize the spatial materials and outer spatial lighting techniques to embed the tag with the less obstructive to the user. And so that they can increase the usability and maintain the appearance for the products. Yes, the main issue here is that they are not edible at all, and the methods do not allow for the tag to be used in the food. So we present here is a method to embed the tag inside the food so that the food can use as the data storage without requiring external package. So our constraint is that to embed the tag inside the food, it should be maintained the appearance and eating experience so that it's less obstructive to the user and should have no strange taste because it's the food, so that the user can consume the food without any worry. So to embed the tag inside the food, we utilize the infused space of the food that adding the space inside the volume of the food. Or adding the secondary material as the infill so that the internal structure can be separated into two different light reflections property. And to handle whether we should embed the tag with the airspace or with the difference material, we set the criteria to our informal experiments. And given that the size of our standard cookie is 5 by 5 by 0.8 centimeters, we just set it up. And the standard QR codes that require at least 13 by 13 modules might need infrastructure, at least 70% of the space to use. Therefore, if the required infills is than 70%, we use the airspace to generate the tag. Otherwise, the system assigns the secondary materials to generate the tags. For more detail, please see your paper. And all the food embedded with tag are printed with the pressure control 3D printer that we are customized for the foods process. However, the commercial foods 3D printer products can be used in our similar to our method, can be worked with our method as well. And after printed, the cookies or the food we are using is baked with the standard process. And to extract the tag from the food, we utilize the image processing techniques through the backlight illuminations. As shown in this setup, when the backlight illuminated, the tag is appeared on the camera. And our recognition process starts from capture images in K-scale, enhance the intensity of the image, at the same time reduce the noise. Then we convert the images into a binary image so that it can be read through the standard QR decoder. And we conduct several experiments for fabrications and recognition of the food tag. And we select some experiments to explain in these presentations, and for more information, please see our paper. So first we conduct the experiments to confirm the principle and the printable and the recognizables of the tag with airspace. And therefore, it is important to determine the printing solutions so that the top layer is not collapsed after baking. As you can see in this picture, we have found that with the airspace, this top layer of the surface might be collapsed due to the hot air accumulated inside the airspace. So it might be collapsed or whether it's generated bubbles on the top of the surface. Solving this issue, we integrated the small holes on the bottom layer of the surface and the support over the full structure so that the surface is not collapsed and might be look really nice like this. And we compare the results when making the small holes with the support and the printed without small hole. Our result found that the small hole with support could make the better appearance and at the same time recognizable by the camera. And for more detail, please see your paper. And since each food material provides with the different transmitted rate and absorption rate, we conduct the experiments to measure the transmitted light spectrums that better recognizable by the camera through the marker embedded with the secondary material and those with the airspace. And we find that the cookie doughs better transmitted with the light at a wavelength of 550 nanometer to 780 nanometers, while the embedded area with the airspace is brightest comparing with the area with the backed cookie dough. Moreover, with the specific wavelengths as 680 nanometers, is increased overall contrast of the embedded tag. So we usually use the red colors to decode our QR code. And here is some potential applications that when the food tags are available for the user. Since the food surface is clear from any embedded marker, it can be used for the spatial augmented realities, in which the projector can project this image on the top of the food, and while the marker is read from the bottoms. And put forward for the human food interactions, we would like to use a tag for the game controller to play them out, but you might need another food to be used for the controller after you eat it. We put some limitations here for the discussions. So first of all, we are using the cookies at our food target right now. We also test it with the meat, and it looks like this. It's not that nice, but it's readable through our decoration frameworks. Maybe in the future, we should improve on these directions. And second, we only demonstrate with the direct 3D printing. We believe that another fabrication method like moldings might be works, but we didn't go forward for this in this work. And finally, the works are limited by 13 by 13 modules for the QR code and 6 by 6 for the AR marker. We can only embed it like 6 alphabets and the ID. We can employ the larger size of the QR codes, but it might be require more high complex or high resolution 3D printer that we don't have it now in our hands. We will investigate this on the future works. And this is the summary of our works, and I want to get some more time for the questions, and this is all for my presentations. Thank you.
Super. Yeah, we have time for a few questions. I see a question there. Can we get the SV? I have to say that meat 3D printing was very interesting.
Okay.
Very cool work. Ken from Chicago.
Okay.
Random idea. I thought about applications that this, like making cookie, people do for like gifting and giving to someone. I thought like encoding secret message for someone and doing something like that would be cool. I don't know. Was there any like scenario you thought something like that?
Yes, that is one of the nice idea. I just watched the Fantastic Beast on the airplane. They are doing like you can put this QR code. I mean the embedded text inside the cookie and put into the tea. Then you can see the hidden message after that.
Okay, I need to watch the movie.
Hi, Godon from MIT-CCL. Great work. I also think it could be interesting for logistics or supply chain tracking and things like that. So very interesting possible applications. I was wondering if you considered using different types of barcodes, such as data matrix barcodes, for example, because they can be made much smaller, or if that's perhaps this provided enough capacity. So I was just wondering.
The matrix can be used, can be printable. What we found, I mean, we did it in our experiments, but what we found is like we cannot decode it out once we embedded it, since the images that we got from the recognition process is not high resolution enough. So maybe we have to improve on that direction.
Yeah, that makes sense. Thank you.
Hi, this is SIGCHI from Stony University, and I'm really interested in your printer device. So is this your customized printer? Yeah, so is that? Oh, okay. So it's based on the air pressure to press the material down.
Yes.
And I wonder, is there any limitation about the viscosity of the materials?
Yes, they have some limitations of the viscosity, so the materials should be. I forgot the specifics. Maybe we can talk later about this. But what we have done with the printer is like we can put forward the material, and if it's too much extrude, we can reduce it up back. It's like a back and forth process.
Yeah, because I think the food material is the viscosity is very high, so I think, and also there's maybe some particle agglomerations to stock the nozzle. Yeah, so I think it's really cool to like print that high viscosity materials. Yeah.
Yes, it also depends on the nozzle size. We can use the more higher nozzles to reduce the clogs of the extruder.
Okay, thank you.
Yeah.
Well, we still have some question time, so I'll ask a question. Have you thought about what kind of codes would be robust to eating? Because a QR code is not designed to be eaten. Like there's some, error correction, but I think it's maybe not. Do you have thoughts on that?
Not really, but yeah, maybe if the QR code is not good for the eatings, maybe you can use, I don't know, we can try barcodes. So still, yeah, I don't have the answer in mind, but
cool.
Just look forward for that.
Cool.
Thank
All right, let's thank Perinia again. All good. All right, our next presenter is going to be Hua Ma, who's going to tell us about 3D printing conductive sequence. Hopefully you all got to see the demo at the demo session, but anyway, it's going to be very cool.
Ah, thank you very much. Okay. Hello everyone, I'm Hua Ma, a PhD student from the Future Crops project of Keio University in Japan. And this time I'll introduce our research SenSequence, smart textile using 3D printed conductive sequence that is researched by me and my professor Jun Yamaoka, collaborated with Zozo Technology.
And in this research, we used traditional sequin embroidery as the basis and a 3D printer to expand the design space of sequin materials and structures. We developed a new 2.5D smart conductive sequin textile with multiple sensing and interactions called SenSequence. And we also provided users with a customizing system for automatic design and manufacturing. There might be some people who are not quite sure what sequin embroidery it is. So it's a traditional embroidery technique, has a wide range of applications in textile manufacturing. By changing the size, shape, color, arrangement, and embroidery method of sequins, we can get various types of sequin textiles. It has a semi-dimensional structure, a simple embroidery method, and unique haptics, and also has interesting interactions such as flipping sequins. So here's a question: why I choose sequins embroidery to make a new type of smart textile? So many kinds of smart clothes are being developed now, and more HCI researchers and fashion designers are getting involved in the development of smart textile together. And most of them are based on the traditional fabric manufacturing process by using some smart materials such as conductive materials, or by improving the manufacturing process such as using 3D printing technology to integrate electronic components and smart accessories into garments in a more fitting way. What smart textile you can develop until now, the main focus is on making the devices carrying smart functions as small, thin, and light as possible so they can be hidden in the garments. Although this looks more aesthetic, but I think it essentially treats electronic components as a cumbersome part of garment design and does not expand the design space for smart fabrics and smart garments. Of course, they have continued to explore the design space, for example, through the combination of craft and external decorative devices to achieve smart functions. And as for fashion designers without technical background, I think modularity and easy to understand prototype approach are also very important. So if we want to further involve with smart textiles, we need to expand the design space, make the design and manufacturing tools easy to learn, and have the possibility to explore more ways to interact. As we said before, sequin embroidery meets our needs perfectly. In terms of the design, sequin embroidery consists of two parts, sequins and fabrics, and both parts are decorative, so we can have a very large design space by 3D printing and digital embroidery. And since the sequin part is detachable, it's very friendly for prototyping. And by generalizing the design principles, we can further reduce the learning cost of designing. So in addition, it is possible to explore more ways of interactions by changing the design. Now I'll introduce SenSequence from 4 parts: design space, automatic design and manufacturing system, and applications and user studies. So the whole system consists of 3 kinds of materials: 3D printed conductive sequins, fabric, and sewing thread. And in addition, we also need a computer. The fabric can be changed into a double layer to make more complex circuits. We can also choose different hole positions and embroidery method to create different ways of interaction. As for conductivity, basically the length of the conductive material between the electrodes determines the amount of resistance. We can also change the size of the sequence and the thickness and the area of the overlapping parts and the fill rate to control the resistance value. However, the circuits can be kept in the flipped state by placing the holes in the center. In this way, we can create a circuit like a slide switch. On the other hand, since the material is conductive, it is possible to design a circuit that detects changes in capacitance. For the parent's design, we can adjust the circuit's stability by changing the shapes of the sequence. The shape of the sequence will also affect the softness of the textile, so we can create different textile structures by adjusting the curvature of the sequence. We can also add texture to the sequence to increase tactile feedback and adjust the friction between the sequence to ensure circuit stability or just make it look better. And we also make the sequence with locking structure. Combining the above design primitives, we can freely arrange and combine different kinds of sense sequence. We can also use non-conductive sequence to separate the sensing area. By connecting to a computer such as Arduino, we will get different sensing effects depending on the properties of the sequence. For example, we can use flight sequence to make touch sensor, pressure sensor, and motion sensor, and we can also use UIST sequence to make bend sensor or strength sensor. So we have concluded the design space of sense sequence. We can use this board to understand the design primitives and design principles of sense sequence, which will be further verified in the session of application and user studies later. So next I'll introduce the automatic design and manufacturing system of sense sequence. We first used the Grasshopper add-on for Renault 06 to design the size, thickness, holes, position, and overlap area of sense sequence, and to get an estimate of the resistance values. Then we will export STL file for 3D printing and SVG file to determine the embroidery position. We will import the SVG file into the embroidery design software that comes with the digital embroidery machine, and then make the stitch adjustments. As for the hardware part, we made the special embroidery frame to hold the sequence, where the sequence will be printed out line by line, just in case it can be fixed on the frame. To increase enough space for embroidery, we will leave one row empty for each embroidery, such as 1 3 5 rows before 2 4 6 rows. Finally, we fold the fabric to separate the sequence and finish the making process. So using the above design space and manufacturing tools, we have prototyped 2 applications. For the first one, we have created a garment inspired by fish scales that can sense body movement. By using non-conductive sequence to separate the sensing area, we obtained a total 84 sensing points. By controlling the LEDs inside the garments with signals generated by the collision between conductive sequence, we visualize the body movement. Also, we can interact by touching or even use wings. We also created a prototype that can recognize the movement of the ankle. And like the previous application, we used the semi-locked structure of the UIST sequence to create a band sensor this time. That means we can change the sequence shape, size, and arrangement to match different functions and different body parts. In summary, we can see that application 1 and 2 use completely different design primitives and get completely different sensing effects, which can show that we can achieve or even create some interactions by choosing different design primitives. And as for the user study, we invited 8 people with basic design and programming system skills to make smart wearable atoms following the design space we had summarized. There are no additional restrictions on the participants' design other than introducing the design space to them. During 2 hours, designers were free to use their imagination as much as possible and create their designs after briefly understanding the design principles. They have give full play to their imagination and create works such as eye mask to detect muscle movements around the eyes and smart raincoat. For the part of sequence design, participants were usually more interested in sequence with complex structures and also came up with ideas of modifying existing sequence, such as making an extra hole. In addition, the detachable properties of sequence allowed them to modify the prototype several times, and sequence embroidery requires no special sewing scales and could be done independently by all participants. For the part of overall appearance and circuit design, they were very clear about the design options after understanding the design space. Based on the results, we summarized how to choose the best shapes and materials for the sensing interactions that users want to implement. These items are all referenced from the design space. But the table is only used as a design reference. We don't want to limit the imagination of the fashion designers too much. And we hope fashion designers can break through the limits of technical ability and explore the development of smart functions with appearance design. In the future, we want to try more materials and explore more ways of interaction, such as color changing and deforming materials or some biomaterials. And in addition, we'll explore more user studies to develop easier design methods and design tools. That's all. Thanks for your listening.
All right, questions. Okay, well, I will get us started with a question. So you talked about one of your participants made a smart raincoat, which I guess would sense the water on the outside of the garment. Have you thought about sweating and how sweating would affect these sequence?
Yeah, sweating is. I think sweating is also can be detected by the conductive materials, but it's too weak. So maybe we should design some shapes or some. I'll use some textures to make the sequence to detach our skins more apparently. Yeah, I think as for the designers, we can try a lot of shapes and a lot of different imaginations, and I think that would be a good inspiration for me. Yeah, maybe I'll try it later.
Cool. I guess another thing is you sort of have this, you can control people's motions at the same time that you sense them, right? Because you said it modifies the stiffness of the fabric. So have you thought about, they're sort of like they're not a passive actuator, right? But they're like a limiter. Did any of your designers explore that?
So can I just ask you again?
Sure. So the sequins, if you make them really big, it means people can't bend, right?
Yeah.
And so did your designers look at that as like, because you can sense when it bends, but you can also stop it from bending?
Yeah. I think, it's, maybe we can change the materials of the sequence. I just use the conductive PLA, which is not soft enough, maybe we can try conductive TPU or something. We can change the softness, or we can just use some other structures like lighting or something to make it more softer.
Oh, cool.
More softer.
Yeah. That sounds great. All right, let's thank Hua again.
Thank you very much.
All right, for our final speaker, we have Justin Moon, who is going to tell us about shape memory polymer, which is something I have never worked with before, but it sounds awesome.
Okay, hello. My name is Justin Moon. I'm from KAIST, and thank you for coming to my talk. And on behalf of my collaborators, Han Lee, Jian Kim, and Andrea Bianchi, I'll be presenting shrink cells. Shrink cell is a localized and sequential shape-changing actuation via selective heating. So shrink cell is, I said before, is a shape-changing actuation with a local heating mechanism that is embedded and 3D printed inside. And we use two materials for this fabrication. We use shaped memory polymer for shrinking and conductive filament for heating the internal material. And additionally, not just a linear shrinkage, we could also render 4 different motions, basically bending motion in 4 different directions. And also, when you have a multiple shrink cells, you can also actuate them in a sequential motions without any additional wires and none of the microcontrollers also inside. So I want to briefly mention how actually shape changing works. So when you 3D print a thermoreactive polymer, which we use is shape memory polymer is also one of the type of it, you build a residual stress inside the material. And after the printing process, once you cool it down and reheat it above its glass transition temperature, you kind of release those residual stress built inside the material, and therefore you have the shrinking motions along the printed path. And in literature, you can see this in thermo, which utilizes 2 different material with different residual stress and also a printing speed to render different bending direction. And A-line, which uses same material, but by playing with the printing path, you can have a curvature geometry from a linear printing model. And lastly, in shrinkage, they use the different infill patterns and infill ratio to control the shrinkage ratio of a 3D printed geometry. However, they were mainly relying on environmental stimuli, such as hot water or like a hot air blow or oven. And in our paper, we want to focus on how we could locally, selectively, and sequentially heat and activate the shape-changing actuation of a 3D printed object. So I want to briefly mention the relationship between the conductive material and the temperature. So when you joule heat it, normally the larger cross-section is, the less resistant it is. But we have found that with the limited current, the smaller cross-section has the highest temperature. And this is because the equation of the power, where I is the constant and the temperature is directly proportionate to the resistance of the material, which is the cross-section of the geometry. And we want to see whether this phenomena also happens when we have a geometry with various cross-section area. So we have this material, we have this geometry with 3 cross-section area having 3 different resistance for each region. And as you can see in all the combination, regardless of their order, the smallest cross-section area has the highest temperature, and the lowest cross-section area has the highest temperature, and the larger cross-section area has the least temperature. This also means that we can selectively heat a 3D printed geometry without having additional wires attached to each region. And we want to apply this knowledge to our shrink cell design. So we don't want to shrink in the entire geometry. We want to selectively shrink the particular regions of the geometry. So we have this hot region for shrinking. And the rest, we relatively want to have the cool temperature because we do not want to destroy the overall geometry. So we apply the same logic here. So we have a zigzag structure that heats and shrinks along the printer path, and also having the smallest cross-section area, and the other area having the larger cross-section so that they relatively heat less. And we also have an insulating wall in between so that we prevent any electrical shortage while we have a shrinking, or during the shrinking process. And we also stack that on a layer by layer to kind of maximize the shrinking force of our shrink cells. And as you can see, when we power when we power the shrink cells, it locally heats without relying on external stimuli, and it heats up to around 50% of its original length. And now we have the shrinking motion, like a linear shrinking motion. And by selectively heating the particular region of the geometry, we could have a 4 different bending motion, as you can see in the video. And we also conducted a technical evaluation on, we measured a shrinking rate and shrinking force and the bending angle. And overall, we have found that yes, we can shrink with a lower current limit, but we have observed that the higher the limit, you have the higher the shrink rate. And also, we obtain around 0.8 Newton of a shrinking force. And also, we also observed that the bending angle is, you could obtain the more bending angle when you bend toward up and downwards than the right and the left. And then now we have this selectively heating and local heating, but then we didn't want to really end up here. And we also had as a question how we could embed timing into the shrink cell structure so that we don't have to manually switch off the power supply. Or we also wanted to have a sequential activation of a multiple shrink cells that is 3D printed in a single geometry. So previously, our structure had this large cross-section area that was passing through the current from one zigzag structure to the other. But instead of that, we printed a very tiny geometry, basically a one printing path that connects the two structure, and we call them the fuse. And to recap, from our previous material study, the smallest structure area has the higher temperature. Therefore, this fuse has the highest temperature among the entire geometry. And once the shrinkage happens, the insulating wall that was in between the two zigzag structure pulls and breaks the fuse, therefore cutting the current flow and stopping the shrinkage. And we could have a different variation of timing by having additional fuse that is 3D printed inside the mechanism. As you can see in the video, the top one is without the fuse and the bottom one is with the fuse. So you can see that the bottom shrink cell stops under 27% of shrink rate, while the top one shrinks up until 50%. And we also conducted a technical evaluation with 90 freshly printed samples, and we have observed that the timing, the double fuse lasts longer than the single fuse, and it shrinks more than the single fuse. And we also wanted to connect this fuse in series. But as you can see in the geometry, like geometrically speaking, they are in a series connection. But in an electrical circuit design, they are in a parallel, connection. So when you first power this double shrink cell, you have the first cell that is actuated because the current is looped inside this first loop, first electric current circuit loop. And then once you break the fuse, then you suddenly have this giant loop. So the current passes through on the second cells, and therefore you have the second cell, shrink cell activated. And once the last fuse break, you have no current passing through, therefore the shrinkage stops by itself. And also, you could have different bending motions or different actuation types based on this, based on the two individual. You can control them individually, cell by cell. And we want to have this double cell, multiple of it in a single 3D printed geometry. So they are connected in parallel. As you can see, these four cells actuate sequentially one by one, and you can also check from the heat cam. The last cells only heats up when the before fuse breaks up. And we also came up with this user application where you could just introduce a simple cuboid geometry and automatically changes this cube to a shrink cell pattern. And you could customize the number of cells, number of fuses, bending direction, and even the nozzle size, because we are incrementing the dimension by the size of the nozzle. And here you could see that the mini table that is self-standing by itself. And also a flower mood light that is built, LED built inside, and you see that after the shape changing, you could still use it as a LED mood light. And also, this is a phone holder it's a collision-free actuation by sequentially lifting its two legs first and the last leg later. For your fancy iPhones. And for the future work, we were planning to integrate a sensing mechanism for your actuators. And also, we want to generate a simulation tool so that instead of designing your circuit for the rest of the geometry, we want our software to do that for the users. And we also want to explore different morphing structures. Now we have this linear zigzag structure so that it's very limited to a linear direction, such as like shrinking, bending in 4 different directions. But we also want to explore coiling and wrapping. And for the limitations, our material has a high resistance. We took an advantage of high resistance by heating, like joule heating, but we still want to explore how we could minimize the resistance so that we can really scale it up. And that's also another limitation. The shrink cells are small. We want to have in a large scale so that we want to find a different application that is more usable to many more designers. And also, our shrink cell is not non-reversible. It's not repeatable. It's a one-time actuation, and we want to explore different shrink rate or different material and different mechanism to heat up and apply it in a reversible and repeatable applications as well. So in conclusion, shrink cell is a locally actuated shape-changing actuation that is fully 3D printed, where you can selectively heat particular regions of the site for different motions and have a sequential activation to prevent any collision while shape-changing motions. Thank you. We are researchers from KAIST and Texas A&M. I'm very happy to take any questions.
All right, I see a question in the back.
Thank you so much. This was really interesting. Marwa from MIT CSAIL. So you mentioned that one of the limitations is basically having these cells, no longer than 42 millimeters. I was wondering if thermal degradation was one of the limitations, and whether you considered, like, instead of having one-sided heating, like two-sided heating, or.
Yeah, definitely, like a thermal degradation, one of the limitations we had, and that's because of it's also in our technical evaluation. The longer it is, the resistance increases as well. So with the current a power supply we had, we weren't really able to put like a 20 or 30 milliamp constant current. So that was one of the limitations. Of course, we could just buy very fancy and give a very high voltage, but we thought that's why we just put it into our limitation, and we really think different materials with low resistivity but high heat, with high heat endurance, will solve this issue.
Hi, this is Chen from Stanford University, and it's really a cool application. So I have 2 questions. The first one is, I wonder what kind of thermoplastic material print and what the printing mechanism you used?
So the 2 materials that we are using is, for the conductive filament, we just use a protopasta because it was the most durable material that under heat. And for shrinking, we use a shape memory polymer that is produced from one of the companies in Japan, which is very accessible by online. We mentioned the website of the producer on our paper, and you could check that from our paper. Thank you.
And what printing mechanism?
We just use a flash forged dual nozzle printer. Any type of dual nozzle printer will work.
Okay, and so wonder, did you cover any materials outside of the material? When you hit the thermoplastic material, it will be sticky, and
we haven't really observed any stickiness when we were heating. But the reason why we choose this particular material is we actually, we put in our paper, we compared this SMP material with a PLA. And while PLA was really efficient for the 4D printing, you bend manually, and after you heat it, it comes right back. But the SMP SMP was able to build higher residual stress. So as you can see in our stats, the PLA nearly doesn't shrink at all under high temperature, but you could see SMP shrinking up to 70% of its original length.
Okay, thank you.
All right, last question right here, really quick.
Hi, Koya from the University of Tokyo. Great talk. And I'm wondering how many elements you can fold sequentially at maximum? I mean,
I have a slide for that. I have like 50 slides of appendix.
I see.
So this one is the one we tried with in total 6 cells. And as you can see, you could also have the sequential movement with the 6 elements. But of course, there are limitations because we have to deal with this resistance, and we cannot really control how much current is flowing inside. And that's one of our limitations. The resistance happens not just on the shrink cell, but the rest of the geometry tree that is supplying the current through. And we want to explore how we could simulate this for the future work as well. But thank you for asking.
I'm guessing the sequence highly depends on the initial position of the components.
Yes, yes. But also that is up to the user. If you have a different outlet for the power supply, you can control in a different position and obtain different sequence as well from the same printed geometry.
Thank you.
Cool. All right, let's thank Justin and all of our speakers again. As a reminder, you can vote for your favorite talk using the QR codes on the back wall. And now we need to get ready for the vision talk, which will be also in this room. So everybody sit tight, get excited.
Hey everyone. Oh, it's loud. Session 9B is going to start in here technically right now. I'll give it about a couple minutes for people to just filter out and in. Okay, so hi everyone. I'm Amy Pavel. I'm an assistant professor at University of Texas at Austin, and I'm very happy to welcome you all today to session 9B, Search and Exploration. I think we saved the best for last. This session is awesome because it's really relevant to us as researchers. So today we have 6 papers that together present a vision for how advances in automation can support how we creatively find and synthesize information. These papers suggest that in the future, we'll have better ways of exploring scientific literature, organizing our own files, and screenshots from our searches, thinking of what to search for next, and even reflecting on our own writing as we go. So I'm sure you'll have lots of questions. Gotta get one in before the end of WIST. So when you have a question, you may either come up to the mic or raise your hand and we will bring a microphone to you. All right, so we'll first begin with some lightning talks by Beza and Michelle. Beza is looking for PhD student positions and Michelle is looking for potential internship opportunities for the summer. So if you're interested, please get in contact with them. Lightning talks? Oh. Oh, do we not have lightning talks? Oh, the system's gonna do it. I see. Maybe we'll go ahead and get started because I think we're going to run a little close to time. And then maybe we can play the lightning talks after the first talk. Oh, you can play it. Okay, maybe after the first talk. All right. So our first talk is Interweave, presenting search suggestions in context scaffolds, information search and synthesis. This is presented by SIGCHI Polani. And she's on the job market this year looking for both tenure track faculty positions and research industry positions. So get in touch. And yes, you're welcome to come up to the stage.
Hello, everyone. Does this work? Yes. Can you hear me? Great. Thank you so much for being here. Let me start my talk by just delving right into the motivation for this project. Search engines are used daily by millions of people to do a variety of tasks, including not only navigating to other websites, shopping, learning new facts, but also searching for more complex and exploratory information goals. These can be where, say, academics like us are reviewing literature on a topic, or lawyers doing case discovery, or individuals like us making decisions like planning a trip to Bend, Oregon. These information goals can be either really simple, such as finding the capital of Oregon, which is Salem, by the way. I didn't realize it's not Portland. Or more complex goals, such as finding the 10 best neighborhoods to live in Oregon. And these goals can be either really concrete and clear information goals like these, or they can be really abstract and fuzzy, like learning something generally about Oregon, or wanting the information to plan whether or not to move to a beautiful Bend. During these more complex and abstract exploratory searches, users often grapple with a lot of information over multiple different sessions and tabs. And as people struggle to make sense of all this information, store it across the different sessions, and even share it with others, they start to take notes. And there are many different challenges that go around searching, exploring, and making sense of all this information, especially these vast amounts of disparate information. So let's walk through a user scenario to understand these pain points. Imagine a policymaker wanting to explore a topic that they're unfamiliar with. Say they want to understand and evaluate the many ways in which the COVID-19 pandemic affected our environment. People who are just starting to explore a new domain, or those who lack well-defined information goals, often struggle to articulate these fuzzy information goals into concrete search terms. They might have not yet learned the domain-specific language that could help them translate them into concrete search queries. And as she starts issuing multiple different searches and reading multiple different articles, she's encountering a vast amount of information. And it's hard to keep track of all of it. It's hard to synthesize and connect all this newfound information with things that she already knows. So to make sense of this information, when searching and reading articles, she starts to clip and paste information into notes, writing comments and organizing this information into sections and different subtopics. But every time she has to switch back and forth across contexts and applications to make sense of information in one application and work on things there or send emails to people with the task of searching and reading articles and information sources. So we translated these user challenges into our design goals for Interweave. And so our design goals were to help users articulate effective queries to explore any information space, contextualize and make connections across newly found information to already known information, and integrate search suggestions into this evolving thought process of their current work structure or knowledge structure. So to explore the potential of weaving query suggestions directly into the searcher's knowledge structures of work or work context, we developed Interweave as a browser extension and a Wizard of Oz prototype. So to illustrate the user experience, let's just extend the same user scenario as before, someone trying to learn about the environmental impacts of COVID-19. So as they start to search on this topic, the Interweave system pulls up an infinite 2D notes board with the topic next to the web browser. This is their sense-making workspace. And as the searcher reads articles, she writes down what she finds. Here she has notes on how there was a decrease in wildlife killed on roads, in the water, and even in the air because of a decrease in land, air, and water transportation. However, there seems to be an increase in global plastic pollution because of single-use plastic protective gear. On parsing these notes and searches, the websites that she's read so far, Interweave presents suggestions on the document title to broaden the topic exploration by presenting phrases that are related to the topic, but conceptually far from what is mentioned on the board. So for example, here it starts to suggest food packaging, illegal poaching of wildlife, and how ecotourism was affected as it relates to environmental impacts of COVID-19. Clicking on each suggestion adds the adjoining notes text and issues it as a query. So say food packaging is issued as food packaging as an environmental impact of COVID-19, because that's what is attached to that text. She adds information that she found on this topic to her notes and organizes her notes to not only include the positive impacts, but also now the negative impacts. And as the clusters of information appear, Interweave looks at this and says, why don't you go dive deeper into the cluster subtopic? So for example, here it suggests other negative impacts like the increase in invasive species or the decrease in heritage conservation and the decrease in recycling activity. To keep track of which suggestions have been seen on the board versus not, and which suggestions have been clicked on, we kind of have a low lighting thing happening. So if you've not seen a suggestion, you have it in the darker green, and then when you click on it, it fades to a lighter green. And once the user clicks on a suggestion, it is grayed out within the list at that location. And as more information is added across clusters to explore relationships across the different clusters, Interweave presents suggestions like here between the positive and negative impacts. It suggests the Business Act on Climate Pledge, which can help turn negative impacts into positive impacts, and environmental racism as a third variable that the user can delve into to better understand the different complexity on whose environment was impacted in a positive or a negative way. So these are the cross-cluster suggestions. And lastly, Interweave also presents suggestions to delve deeper into any specific unit of information. So for example, here there's a card that talks about the decrease in bird strikes because of the decrease in air travel. And Interweave sees this and suggests other effects of the decrease in air travel, such as the decrease in air pollution, the ozone layer healing, and also how during the pandemic, the land use patterns of birds changed. Okay, that was a lot about the environmental impacts of COVID-19, but here you can see how basically Interweave is trying to push someone to explore different things at different levels of their sense making. So now on to the exciting part of investigating how the presentation of search suggestions within the worker's context and knowledge structures impact search, sense making, and their learning behavior. And do users think this is even useful? So we conducted a between subjects experiment where we compare Interweave's in-context placement of suggestions with a conventional list of query suggestions, the way we usually see suggestions in web browsers. 34 participants were asked to search on the web on an exploratory topic, one of them being environmental impacts of COVID-19, another being the future of space travel, while they also collected information and took notes in their sense-making workspace. We collected logs of each participant's interaction with the search browser and the sense-making workspace, and before and after searching, there was an assessment of their topic knowledge using surveys. And at the end, we had a retrospective think aloud interview to gain insights into the different challenges and strategies that they were using when searching. Analysis shows that compared to seeing a list of query suggestions in the web browser, Interweave participants issued significantly more queries, particularly using the suggestions that were presented to them. They also gathered more information and made more connections across different subtopics towards a more holistic understanding of the topic. Interweave participants also reported a significantly greater gain in knowledge. This is comparing post-task to pre-task knowledge, discovered more domain-specific terms and idea units compared to the baseline participants. Please check out our paper for additional results, user insights, and even the wizard's insights, because that was a Wizard of Oz prototype. This paper's key takeaways are that the user's ongoing work and evolving structure of knowledge and work can be inferred and leveraged to present suggestions in a more intuitive and useful manner. And presenting search suggestions within the searcher's workspace or sense-making context can actually accelerate the information search, synthesis, and learning, and betters the user experience. There's more results in the paper, so I hope you go check it out. Thank you to my amazing collaborators and support from UCSD and Google. Thank you.
Yes, thank you so much for the great talk. If you have questions, please raise your hand. And while we're waiting for people to raise their hand, I will get started with one. So it looks like the user study investigated how people used Interweave alone. But I'm curious what you think about, like, if they're going to use them together, Interweave together. If that's something you've thought about, how it would work in like in a collaborative situation. Yeah.
It's a great question because most knowledge work is often collaborative. So there's people who are going off on their own, exploring different parts of the knowledge space, much like us doing literature review with our collaborators, for example. We all go search in different ways, but often the work is repeated across different collaborators, and it's hard to come up with a shared representation of what's going on. So hopefully if we kind of, what we're doing in Interweave is kind of monitoring their activity and their the knowledge structures that they're creating, their mental models, and hopefully we have that, we can scale that in a collaborative sense as well, so we can kind of see other collaborators' work and share that, and hopefully kind of help coordination in a manner where the search suggestions are not pushing them to explore the same thing, but to explore different parts of the same information space so that they can come later and discuss and have a shared understanding.
Valkyrie Savage, University of Copenhagen. I'm curious about knowledge and searching and how it's not like a neutral thing necessarily. So as we're in America, you know, people have this idea that like sometimes experts are suspect, and I'm curious if your system, like when you're thinking about people's mental models, how are you thinking about like their trust of different sources, and like how do you use that to present search queries that like might align with what they already believe, or else like cautiously push a different direction?
That's a great question, and I think about that quite often, actually. And in many ways, it does kind of inspire some of this work, because while this is kind of pushing them to explore things that they already don't know, which might be helpful for a research project, like an advisor saying, hey, go search for this thing. It can also be helpful for things like misinformation and echo chambers, because often you can go down a rabbit hole and you're looking at the same things, and a system like Interweave can come in and say, hey, I see you've been doing a lot of search on this, and you seem to be kind of focused on very specific parts of this topic. So for example, here in this example where I said, oh, this person was mostly focusing on just the positive impacts of COVID-19 on the environment, but then the system comes in and says, hey, no, there were negative impacts, and maybe go check them out. And hoping that translates as well, but I would love to kind of continue to do more research to see if that pans out.
Cool.
Yeah, we have time for one more question while in.
Can I'll make the short. Bala from Microsoft Research. Really cool work. So just building off Valkyrie's questions, are you suggesting that it is important to consider recommender systems that necessarily don't recommend what users want, but what users haven't explored?
I think that's kind of a premise that I work on, for sure, that it is important to explore things that you don't know, that are conceptually far from what you already know.
So are these like anti-recommender systems?
Yes, hopefully disrupting someone's thought process to be more creative. But also, like with Interweave, the idea is that at different levels in their knowledge structure, it recommends different things. So at the topic level, at the document title level, it's recommending things that are pushing them truly conceptually far to things that haven't been written about on their document at all. But then at the cluster level, it's saying, hey, you can delve deeper into this cluster, or you can check out other subtopics that could be potentially other clusters or subtopics within this. And then at the notes level, it's saying go deeper into the notes. So there's this, actually one of the results I didn't share on the slides today is trying to find this kind of Goldilocks effect, where people actually liked suggestions that were at the cluster level more, and they clicked on those suggestions more. They didn't want too broad of a suggestion, and they didn't want too specific of a suggestion. It had to be at the right Goldilocks level, almost. So I'm curious how that translates onto like long-term knowledge work, where you often want to sometimes just get a broad overview, and sometimes you want to delve deeper and actually read the details.
So thanks for clarifying that. That's an amazing categorization.
Now we have a lot of new stuff.
Hi, I'm a further CS student in Chicago.
I'll change the sound setting. Is it this one? Sorry, trying to get the audio working. Maybe I can just do it really loud.
Hi, I'm a further CS student in Chicago, where I've worked in Professor Lopez's Human-Computer Integration Lab, thrilled to be attending my first EAT-SAI conference at WIST. During my time in the lab, I've been involved in two major explorations with the help of PhD students in my lab. Firstly, I worked on advancing virtual reality, specifically trying to bring more senses into virtual reality experiences. Secondly, I worked on engineering a software system that assists people with taking more ecological steps in their prototyping. This work, I explored both the software side of HCI, but also took my first steps into hardware building. In my most recent engineering course, I built a wearable device that explored the idea of sense of fashion surpassing brand or color, but being about interactivity following this idea, I built a custom actuator bracelet that blooms using proximity sensors with capacitive touch sensing to switch between modes of information. I've also explored HCI for a lab hackathon where I came up with the idea to make a physical device coupled with an online system that manages reordering and missing supplies. Following my undergraduate degree, I am searching for PhD student positions that start fall of 2023, but please feel free to contact me and talk about anything HCI or research.
Hi, my name is Michelle Lamb, and I'm a third-year HCI PhD student at Stanford, advised by Michael Bernstein and James Lending. My research seeks to build tools that empower everyday users to leverage their distinctive contextual expertise to actively reshape the design of AI-driven socio-technical systems. First, my work bridges from the language of everyday users to that of system developers. My recent project introduced end-user audits, a technical approach that enables individual, non-technical users to perform algorithm audits of machine learning models to surface harms and perspectives that fall outside of what current auditors and centralized institutions might think to test. Second, my research bridges in the opposite direction from the work practices of system developers to the concerns of everyday users. Here, my work provides cognitive scaffolds for ML practitioners to foreground human values as they build algorithmic systems. It's so nice to meet you all, and I'd love to talk with you about research, hobbies, or anything else.
Awesome. And one more time, Beza is looking for PhD positions. She's right here. And Michelle is looking for internships. Okay. Awesome. Okay, so as our next speaker sets up, we have the paper Thready, an interactive system for personalized, thread-based exploration and organization of scientific literature. And it's presented today by Hee-An-Soo B. Kang. And I will let you go ahead and take it away.
Thanks, Amy. My cheat sheet is all right. Okay. Full screen. Yes. Control. I think this is okay. Perfect. All right. Well, thank you very much. And hello, my name is Hyun-Soo Kang. I'm a PhD student at Carnegie Mellon University, where I'm advised by Dr. Nikki Kitor. And today, I'll be presenting Thready, an interactive system for personalized, thread-based exploration and organization of scientific literature. This was a collaborative project with Joseph Chang at Allen Institute for AI, as well as Yongsung Kim. And in this short talk, I'll be describing the high-level motivations, design, and evaluation of Thready, but please refer to the paper as shown in the barcode on the right for more details. So a big challenge in today's science is that the growth is at risk of slowing, yielding diminishing returns for each additional unit of scientist time. And one of the hurdles that contributes to this is the difficulty of making sense of the relevant literature, which grows continuously, while the support for synthesis and organization remains relatively steady. For example, say a scientist reading this paragraph in a related work section about systems that support paper reading and decision-making might find two interesting sub-threads of research to be cross-referencing and in situ summaries. The surrounding patches of text of these threads might also provide useful context for understanding and revisiting later, and thus need to be captured. The references included in these patches are pre-digested and grouped content by experts that are relevant to this context. So the scientist learning from this text may want to follow up on them later, and so she needs a way to save and organize them efficiently with the context. Finally, the thread-based understanding and structure should be available for papers encountered later so that new papers can also be interpreted using the same lens. Existing work has studied and developed systems for various aspects of the reading and essence-making process. For example, one line of research focused on supporting readers trying to understand unique technical terms, symbols, and complex mathematical equations introduced in papers, or systems for relating documents at different levels and units of text, for example, on a basis of highlighted phrases or paper abstracts. And finally, augmenting scholarly recommendations using implicit author networks or knowledge graphs. These are all exciting lines of contribution. And here we look at yet another underexplored area and ask how might we help scientists easily curate threads of research while reading from across multiple papers without having them lose their focus and flow of reading. So this leads us to propose Thready. Thready aims at helping readers and scientists efficiently leverage other experts' synthesis to facilitate their own understanding of prior art. And here is the overview of the Thready reading interface. Thready is implemented as a Google Chrome plugin. When a user opens a PDF with Thready installed on their browser, it automatically detects it and sends the PDF to the backend parser and replaces the default PDF viewer with its own interface. The main reading interface features the PDF viewer on the left and a sidebar view on the right that contains several subcomponents, which I'll go over in the next few slides. In addition to the reading interface, there is a discovery and overview modal, which isn't shown here, but it pops up when the user clicks on the zoom in button in each thread in the drawer, and that modal shows details of each thread, the clips collected, and additional relevant paper recommendations. I'll first go over the specific challenges that Thready focuses on in more detail, then describe its workflow to follow up on its design and interaction, how its design and interaction techniques actually mitigate those challenges. So a key challenge that scientists face with existing tools is that these tools often don't really support the flow of reading, specifically for synthesis across multiple papers. Maintaining the flow of reading for scientists matters because synthesis is already a cognitively demanding task, and with additional compounding costs from the many subtasks and a kind of fragmented information environment that adds friction to the scientist's workflow, whenever they have to switch between different tools and sites of information can really break their focus and productivity in it. So going back to the earlier example, while reading a paper, scientists build up threads of research. Here it could be augmented reading as an interesting high-level thread, and cross-referencing and in-situ summaries as two of its subthreads. But it's not easy nor quick to capture these threads, references, their relations, clips of the context, and interesting references for additional investigation. For one, there are several manual subtasks that the scientist has to do, such as looking up the references in the bibliography of a paper, finding its details, then saving it into a reference manager, along with saving useful clippings of the context from the text. These subtasks would then need to be repeated for each citation in a thread and a thread in a paper. The scientist will also need to organize the threads into a larger structure in the examples shown here, nesting, cross-referencing, and in-situ summaries under augmented reading. So it's easy to see how these would really add to the demand of the task that's already there. Another sizable subtask is discovery. Scientists would find relevant references while reading, but in order to further grow a thread using a set of papers they already curated in it, they would need to search each paper along its citation chain, which is time-consuming. Finally, the participants of our study commonly describe their current practices as producing a structured artifact from reviewing the literature that consists of the relevant references, clips, and their groupings, but then also when it comes to using them, they may end up just relying on a flat list of entries in overleaf or simply paraphrasing paragraphs they clipped one by one in a Google Doc. So it seems that there is this tension between the effort invested to create a structured artifact up front and when what they find as useful or relevant in the moment of use. So Thready aims at mitigating these challenges. First, the main input mechanism on Thready is a direct highlighting in the PDF to reduce unnecessary switching. Users can highlight the patches of text that contain interesting threads directly in the PDF as shown in yellow here, so that they don't have to switch between the PDF and a Google Doc, for instance. Thready then automatically clips the highlighted text and its surrounding context, and also extracts the references included in it and links their details retrieved from Semantic Scholar by default to to further reduce the unnecessary context switching cost. In the holding tank in the middle, the clipped context from the in-text highlight along with a list of references extracted from it are shown in real time. Underneath, there is a thread selector where users can either select from a ranked list of saved and relevant threads, which are produced using a tree traversal and lexicosemantic similarity calculation algorithm in the backend, or type in to create an entirely new thread. So with these features, users can now save the context clippings and the relevant references together into 2 example threads as shown here. The relevant threads that the user has created are preserved and can be viewed as she moves on to the next paper to read. Thready will detect a new PDF browser tab and sync the data, such as the content and structure of the collected threads in the drawer, and she can also organize the threads into a hierarchy or update the structure according to her changing mental model of the space, and the changes propagate to all the other open PDF tabs with Thready as well. To organize them, she can drag and drop each paper or thread in the thread drawer to nest it under an existing thread, or take a child thread out of a parent thread to create a top-level thread. The user can also add new references from a different paper into an existing thread. And finally, clicking the zoom in button in each thread opens up the discovery and overview modal, where Thready finds recent papers that cite the references included in the thread in real time and ranks them based on the citation coverage over the references. So the higher the number of collected references a candidate paper has cited, the higher it will be ranked. And in case of a tie, we use the cosine similarity between the candidate paper and the average embedding of the reference papers in a thread to break the tie based on the semantic similarity between the two. Okay, so to evaluate the usefulness of Thready and how successful it was in mitigating the challenges described earlier, we ran a within-subject lab study with 9 scientists comparing Thready to a Google Docs control by randomly assigning each of the 2 personally interesting research topics from each participant. And the results show that participants collected twice as more clips and references using Thready than control in the same amount of time, and their subjective ratings of the usefulness were also significantly higher for Thready than control in terms of supporting their collection of clips, keeping track of the collected references, organizing the references into threads, growing the threads with new threads and relevant papers, and staying in the flow while reading. One participant commented that by using Thready, she could see threads while reading a new paper, and this had kind of an unexpected but positive effect of being able to focus on threads of research rather than individual papers as a unit of synthesis. Another participant also commented on the flow of reading in Thready, where he said collecting references is such a pain, such a context break, and especially bad when the papers that he tracked down turn out to be not that interesting or relevant altogether, with the damage already being done in terms of breaking his reading flow. So we believe there's a large design space for future work in this area. And I'll end with some 5 dimensions of user needs and interactions along finding, prioritizing, extracting, organizing, and synthesizing, and the 2 columns describing the current state and what a desired future state may look like along those dimensions. I hope this gives you some food for thought on this topic, and I look forward to discussing afterwards about future directions and other broader topics related to our session today. And with that, I thank my collaborators and Allen Institute for AI for gifts, and I'm happy to take any questions about Thready. Thank you.
Hi, thank you. This is a great talk. I'm Shakir from Meta Reality Labs. I have one maybe like basic question. Is there like a particular type of user that would benefit the most from this? Because from my understanding, it's mostly maybe like, let's say I'm like reviewing a paper submission and I really need to like vet every citation and reference, then it would make a lot of sense. But if I'm like just casually perusing, like I'm like some Joe Schmo and I'm like, oh, this seems like a cool paper, or like, you know, that might be a very different use case for this. So I was wondering if you've thought about that.
Thank you for the question. That's interesting to think about. In our particular user case, it was mostly graduate student researchers who are testing and in need of, basically the task was framed as to read a seed paper and starting from that seed paper, kind of brainstorm and explore related papers that they haven't read before. And so I think the default mode for us, or for a lot of graduate researchers, is to kind of try to find relevant and something recently published that might have some value in terms of doing their own literature review or writing their own reviews. But that being said, I think that's a really interesting thing to think about, the spectrum of use cases, and whether there's some sort of personality traits that's like more maximizing in terms of taking detailed notes versus kind of casually or curiosity-driven perusing. How can we kind of cater different affordances based on those that user profile and that spectrum? Maybe we need more or less refactoring or heuristics or AI-based help to support those different kind of intentions and user profiles. So I think it's really interesting to think about that. But yeah, that's basically my answer. Thank you.
Any other questions? I'll ask one more question while we switch speakers. So I'm curious about if there's any issues with scale with Thready. I could imagine as a PhD student, you're doing lots of, it might work super well in the first year, but what happens in year 5? Like, yeah, anything? Yeah, go ahead.
I think scale definitely will become an issue as with the continued use, especially if people are collecting hundreds of references, thousands of threads from each of them, and wanting to flexibly and on-demand kind of restructure and refactor those threads. We have thought about a couple kind of big ideas around that. One is to help machines kind of scaffold at the collection time, whether there are multiple latent relations between different threads that the user have noted, but also maybe not noted. And then at use time, we can leverage that data, latent data, to kind of intelligently support or surface things that they might find useful. And then the other one is kind of support around the refactoring and like building the heuristics that might also depend on the temporal dimension as well, but using some kind of machine intelligence to help people more flexibly refactor things. And it might actually not end up being kind of a tree structure as we presented here, but rather a graph-based structure, and encoding those relations between nodes and helping machines traverse that more efficiently might be a good avenue for future work.
Awesome. Thank you. Let's thank our speaker one more time. All right. Next, we have Will Brackenbury presenting Summarizing Sets of Related ML-Driven Recommendations for Improving File Management in Cloud Storage. And with that, you can go ahead and get started.
Thanks so much. Yeah, a bit of a mouthful. Hi, everyone. I'm Will Brackenbury, and I'll be presenting this work today. So as personal cloud storage increasingly becomes a storage repository for users' most important files, the difficulties that users have in local storage, such as retrieving files, organizing files, and deleting older unnecessary files, are beginning to become issues in the cloud. So to combat this, many cloud storage interfaces have attempted to offer recommendations of file management actions to users, such as in Google Drive's Quick Access or Microsoft Office's recommended document pane, where they offer recommendations to retrieve files of interest. In research prototypes, such as our earlier work, Condo Cloud, these recommendations may also offer users actions such as moving files or deleting files as well. One such issue that can crop up with these recommendations, however, is that if a single action spawns a large number of related recommendations, then it may be possible for users to miss context and therefore make suboptimal decisions. Our goal with this work, then, was to attempt to aggregate these groups of related recommendations under a single summary, such as the one shown here, that would allow users to understand and to act on groups of recommendations as a whole. To this, we contribute the following. We first describe a novel structure for these summaries of recommendations, which is focused on this idea of verifiability, which I'll describe in a minute. And we also describe a novel recommendation synthesis algorithm that actually generates these summaries. Unfortunately, I won't have time to talk about that today. We also ran an online user study on participants' own Google Drive files that actually compared our proposed summaries against several baselines and found that compared to those baselines, participants were 2.7 times more likely to rate the summary as helpful or verifiable, and roughly twice as likely to state that it induced greater confidence in accepting the group of recommendations. So I'll first touch on the idea of verifiability. So this is adapted from the AI explainability literature, and when we use it here, roughly means that given a summary such as this, and given some files that could potentially be summarized by that, then we term a summary verifiable if it's readily possible to determine whether or not those files are covered by that summary. In the case here, files starting with img underscore, it's likely that one can determine, yes, these files are covered by that summary. If it were slightly different though, such as files with high file name similarity, this might still be generally interpretable to users, but it wouldn't necessarily rise to the level of verifiability. And given that we're attempting to recommend state-changing actions such as file movements and deletions, we think it's critically important that users understand exactly what accepting a group recommendation would be doing. We therefore developed the following proposed summary formats in order to try and take advantage of this. And these formats were a conjunction of two types of predicates, range predicates and set predicates, where the range predicates evaluate to true if the relevant file attribute, such as its date or size, fell within the two constants that were given in the summary, whereas the set predicates evaluate to true if the relevant set attributes, such as the file tokens in a file, or the text tokens in a file, were a superset of the relevant constant in the summary. We presented these in two different formats for our user study, the first of these being a text-based format with just minor formatting enhancements for readability, which we term rules text, and another visual-based format that contains the same information that we termed rules tree. We compared these against two baselines, the first of which is the list of files baseline. And I should note that while this shows a table of file metadata here in the image for this, that was actually included in all of the different summary types. The key difference for this one is that it only provides a small amount of additional information beyond that table, which is because you move, shared, or deleted a related file name. And that's similar to what's currently in many cloud storage recommendation systems out there. Additionally, we compared against a decision tree baseline, and this is a direct application of the same kind of technique from AI explainability literature. And because it's a direct application, an important note is that it actually uses the same feature space as the underlying black box classifier. And because of this, one can see in the nodes of this decision tree that we actually have a feature space that is based on complex similarity metrics between the file attributes. Correspondingly, it's difficult for a user to compute these on their own. And so this kind of leads into the hypothesis for our user study, which is that our baselines may be widely used and they may be interpretable, but we don't find them sufficient for our application because we believe that they won't be verifiable. So the actual study that we ran was a two-part online user study through the prolific crowdsourcing platform, where we recruited participants with sufficiently complex Google Drive accounts and extracted their file data and metadata through Google Drive API and OAuth2. This done, we actually took the recommender system that we developed in our prior work and used this to generate hypothetical groups of recommendations that might be generated for a participant on their same files. We then synthesized a summary of each of the 4 types I've just described for each of those groups, and of these we selected up to 14 group summary pairs to present to them. For each of those pairs, we asked them 8 questions, and the key distinction here is between 2 questions which we term group-based, as these were intended to gain a baseline level of success for the grouping of files that was recommended, independent of the actual summary. And this is based on the idea that if a user answers negatively towards Q1, for example, they believe files aren't related, then it's very unlikely that they'll believe the summary was successful. The summary-based questions were the remainder of the questions, and those were aimed at actually getting a sense of whether or not the summaries had several of the desired characteristics we were searching for. Notably, Q5 is the one that we used to test verifiability. We recruited 44 participants for this study who saw 563 group summary pairs, and they answered questions for each of them. There was roughly an equal distribution of the summary types that was actually shown. And this led to the following set of responses. So the way to interpret this figure: each individual subgraph corresponds to the responses for a single question. And along the y-axis, we have the summary type shown for a response. And along the x-axis, this just shows the percentage of each type of Likert scale response that was given for the relevant question. The key takeaway from the group-based questions is that For Q1, participants indicated that when one's binning the strongly agree and agree responses, nearly 75% of the groups were generally considered related, and then they stated that they would actually accept the group of recommendations if it were offered to them in a practical scenario, about 33 to 50% of the time. Given that this is roughly comparable with some of the data that we saw in prior work that actually examined file management recommendations in practice, this suggests that while it's a hypothetical group of recommendations, it may carry practical relevance. For the summary-based questions, the key takeaway is that when one looks at our proposed summary types, rules text and rules tree, and compares against baselines, there is a noticeably higher proportion of strongly agree and agree responses, save for Q3, where strongly disagree or disagree responses were more favorable. And this suggests that, yes, our proposed summary types are in fact doing what we want, and they display many of the desired characteristics. The one part that went against hypothesis was that the decision tree baseline actually performed worse than expected, and we hypothesized that this might be due to two factors, one of which might be the visual presentation of information, which could be confusing, but additionally, the featurization that I alluded to earlier might also have been a difficulty for participants. To actually disentangle the effects behind these different responses, we performed a series of mixed effects, cumulative, linked logistic regressions. Sorry, that's a mouthful. But each column in the table corresponds to a different one of these models, where the variables along the top of the table are the dependent variables. Those were the Likert scale answers to the summary-based questions. And along the left-hand side, we have the independent variables, which were the group-based question answers, as well as categorical variables for each of the different summary types that was shown for a response, with the list of files baseline omitted. So the table values are actually the odds ratios, which are the multiplicative increase if the value is greater than 1, or multiplicative decrease if the value is less than 1, of the effect of the independent variable's presence on observing a higher output variable. The key takeaway for us is that the rules text variable, one sees that based on the stars, it was highly statistically significant across nearly all of the different regressions, and importantly, its presence indicates a higher proportion of our desired characteristics. So to interpret more specifically, we see that if a rules text summary was used as compared to the list of files baseline, then participants were 2.7 times more likely to state that the summary was more helpful or verifiable, and roughly twice as likely to state that it gave them more confidence in actually accepting the group of recommendations. Our rules tree summaries were also reasonably successful. They do display a higher proportion of our desired characteristics, but not quite as successful as rules text. And this may give further evidence to the fact that the visual presentation of information that it shares with the decision tree baseline may have been at play. Naturally, while any study is imperfect, we believe that the hypothetical study is a good need-fighting type study that demonstrates the potential viability of recommendation summaries, and assuming that these favorable results hold in actual practical implementations, incorporating additional factors such as interactivity into the summaries, such as we see in systems like Wrangler's Small Star, might be a very interesting direction for future work. Thanks very much. I'll take any questions.
All right. While we wait for questions, I was kind of curious if there was a major difference in your experience on how people organize their cloud storage versus their local storage, and if you believe your summaries would also apply to local storage as well.
Yeah, that's a really wonderful question, and I would say that there isn't necessarily a distinct difference. We actually don't have as much good data just in the literature on people's habits on local storage, just because it's more difficult to get that kind of data, particularly on the fine-grained actions that we're kind of examining. Generally, we expect that the techniques would likely generalize, but there are factors such as we do use as one of our variables the percentage of shared users that are on both of two files as one of the features, and so that obviously wouldn't be as useful in local storage, and it would just be interesting to see what other factors would be at play.
Awesome. Any other questions? Let's switch our speakers maybe. All right, I have one more question. You mentioned that you're looking for users that had like large enough, cloud storage. I'm kind of curious, like what that meant in your case. Like how big did it have to be before they would qualify? Yeah.
Yeah, there we go. That's a good question, and in our case, that just meant users that had more than 100 files, had used Google Drive for, we said, 3 months at least, and had at least one shared file. And that was just generally so that we could filter out users who it's like, they joined last week, have 23 files, and it's not really a good file system for trying to do anything. I would say it's not a specific scale at all that necessarily needs to be at play.
Got it. Thank you very much. All right. Our next speaker is Donghyun Hu, presenting Scrapbook, screenshot-based bookmarks for effective digital resource curation across applications.
Okay.
Take it away.
Hello everyone. My name is Donghan, and this is a project that I worked with my advisor, Sungwon Lee, from Virginia Tech. I'm glad to be here to share with you all our project with you. The title of this paper is Scrapbook, screenshot-based bookmarks for effective digital resources curation across applications. Because of the complexity of modern knowledge work, completing a task on computers typically requires various digital resources opening at the same time. As shown in this image, you can see when a worker is writing, they need to open the document editor, web browsers, file manager, dictionary, PDF reader, and all other supporting applications simultaneously. Sometimes multiple windows are overlapping on a computer screen, which constitutes the working context of this writing task. Most computing tasks cannot be completed totally at once, so to be able to resume task later, users need to save resources required for a specific task. Workers typically use bookmarks or file systems for curating their digital resources for online resources or local files. However, having to use different curation methods for different types of resources is one challenge that hinders the effective curation. To solve this problem, researchers have studied tools that could help workers manage their resources separately, like bundling them all into one group together, or structuring related web pages with specific tasks and labels. However, this method still has workers' challenges to manage resources and recognize those bookmarks from the text-based labels. According to this problem, we first conducted a formative study, a large-scale online survey with 125 participants, trying to investigate existing challenges in the curation of digital resources. As you can see, the results showed that the current bookmarks on a web browser is not a primary method for users to revisit websites they want. Most users indicated that they just would like to type URLs or use searching engines to search those websites again when they want to reopen those websites. Open-ended responses revealed that the downside of bookmarks, and participants also considered that it's challenging to keep bookmarks organized and recognize what they are from their names. Overall, the survey participants reported that text-based queues were still less effective. As shown in this screenshot, even though a user might have carefully organized their bookmarks, it's still difficult to recognize target websites based on the textual information. Those names may not be sufficient for users to remember what website it is. Besides, while workers put efforts to organize local files, the participant mentioned that it was hard to remember where these files were, and they typically spend a lot of time on finding those documents while retrieving those resources again. For example, like this participant 16 told us, even though they organized their files while saving them, they still could not remember the name due to similar names or under specific names. So based on the result of this formative study, we came up with the idea of utilizing screenshots to help users curate their digital resources and retrieve them effectively. We leverage humans' ability to recognize information quickly contained in visual cues related to their past activities. Humans can spot a subtle difference between images even after a period of time. Researchers have taken advantage of this and built applications to facilitate the process of recalling their past computer activities on their computers. Next, based on this idea, we developed a macOS application called Scrapbook. In Scrapbook, you can take a screenshot of your computer screen and save any resources captured within this screenshot. When you want to review or retrieve some specific digital resources or computer activities, you can browse all these curated screenshots here, just like browsing a normal photo album. For capturing, when you want to save a set of resources for an ongoing task, you can take a screenshot anywhere on your screen. After capturing a screenshot, you can edit information like title and description to help you best describe this working context, and you can also select which captured digital resources you considered are important and want to save them for the future reuse. When you want to restore your past working environment, you can find the target screen in the collection view I showed before, and you can simply click it, and this detailed view will show you further information about this curation. On this page, you can freely select saved digital resources from the past and to retrieve them again. If you click button to reopen them, selected applications and digital resources will be opened automatically in seconds, saving your time to find them one by one in different applications separately. Besides, screenshots along with textual information available on metadata or users' previous input will also help users to search target screenshots from the collection view. This will be helpful if you have more than 100 screenshots just in one UI. The core idea of our application is that a computer screen contains essential resources for a particular task. However, the screen can be so complicated and have multiple windows opening at the same time. With overlapping windows in the limited screen, it is challenging for users to decide which windows are important for them to curate. Then, which application should we choose to store? One simple option is just to store the frontmost applications only. However, it is not enough to account for all the resources required for a completed computing task. Another option is we can save all running applications together. However, because a worker may have multiple applications opening at the same time, which may be not directly related to the target task, so this may not be an idle option either. And as an alternative, in Scrapbook, we decide to recommend users to store visible applications from a screenshot they just captured. There will be also an option for them to save invisible applications as well, but the initial recommendation will include only visible windows. However, with many opening windows, identifying visible applications inside the screenshot is an incredibly complex problem to solve. Initially, we try to account for all possible cases for the opening windows as much as we can, and we quickly realized that there will be practically infinite possibilities, just like this scenario shows. You can see on this slide, with just 2 or 3 windows, there will be so many combinations laying over the window. So we come up with an algorithm that is able to help us identify visible captured applications from a screenshot. The algorithm converts any window on a computer screen into a 0-1 matrix, and the size of which is same as the whole screen, and we can utilize Boolean operations to determine a particular window is visible or not inside this screenshot. With Boolean operations and matrix subtraction, we're able to dynamically maintain the screen area that is not occluded by a set of windows, or and identify whether a particular window will be still visible or occluded by other windows. From the frontmost window to the last one, once we iterate through all opening windows, or the screenshot is covered fully by windows, we can stop this identification process and provide users with each valid window along with corresponding metadata. And what kind of metadata we provide with users? Such metadata includes the website URLs, name of the files, file paths, the title of windows, and their application names. This information will be used to reopen windows that users created before. Also, users can search any keywords from metadata to quickly locate target curation in the collection view. Next, we conducted a field study to evaluate our application, Scrapbook. To evaluate our applications in the real life, we conducted a field study with 13 participants to let them use Scrapbook freely for 5 working days. Recruited participants were all professionals or graduate students who actively use their computers at work or studying. During this study, each participant was instructed to use Scrapbook, and they will be asked to take at least 3 screenshots per day for any computing tasks. Under their consent, we collected data generated during the study and conducted a semi-structured interview part with their screenshots. The first thing is that we find that participants considered that screenshots effectively help them to recall what they were doing in the past and recognize what the task was all about. Along with visual cues and textual cues together, they were able to shorten the time spending on recording for their previous working and studying. Here is an example screenshot that a participant created during the field study. This participant took screenshots to record their working job applications that they wanted to submit. You can see it has multiple windows and pages, the job announcement, the company's website, and their job applications files. Later, this user can reopen those sites via Scrapbook and continue to work on it, and they don't free to closing them and spend more time on reopening them again. And this is another screenshot from the study where this participant took screenshots of their code to save a version of a function that they were writing before making changes as a way to store as a temporary state. Next, in addition, many participants consider that Scrapbook is helpful being a bookmark for curating resources across multiple different applications. Digital resources are bundled together in Scrapbook via screenshots seamlessly. And users also mentioned that using a screenshot is a good way to help them track the progress of their unfinished computing tasks with rich detailed content. For example, it will help us to answer the questions which slides I was editing for my presentations maybe 3 days ago. Another interesting finding is that some participants considered that Scrapbook serves as a temporary bookmark. We find that screenshot bookmarks are more specific and transient than traditional bookmarks. For example, when the participant watched videos or read some articles, they took screenshots of those particular pages rather than saving the websites that has linked to those videos and articles. And finally, in conclusion, we can conclude that Scrapbook was effective at nudging people to curate digital resources for their recording and resource management. And users can also reconstruct their working context quickly with the help of Scrapbook. Furthermore, we agree that taking screenshots is a promising method for help users curate their digital resources on computers. And thank you so much for your attention, and I would be happy to take any questions.
Thanks for your talk. I'm Matt Bremer from Temple Research. I'm curious about if there was any common salient visual features across the bookmarks that people, or the screenshots people made, and if there were opportunities for visual summarization or visual aggregation that your system could do in the future.
If I understand your question correctly, so typically we just allow users to take one screenshot of their computer screens and they can see all the screenshots in the past. So we haven't considered about the integration of all the screenshots for maybe one really complicated task currently. And maybe in the future we can do more. We'd like to combine more machine learning algorithm to trying to connect or integrate related images together to provide users a more better overview of their past activities. Yeah, if that answers your question correctly.
That was interesting, like you answered a similar question about longitudinal summarization, but I'm curious about cross users, where there's similar features that people bookmark, that similar visual features across these screenshots, across users.
Across users, you mean there are any patterns that across? Oh yeah, I think that's a good question. So we noticed that people, instead of bookmark some, videos or articles for revisit them later, they prefer using Scrapbook that can provide them with visual cues, and for some website they would like to revisit, not every time, but for the future several times. And also there's another common patterns that we noticed, that people like to record some unfinished task as to indicate the progress of some task along the way. Yeah, if that answers your question.
Awesome. I think we have time for one more question as we switch speakers. Yes.
Hey, wonderful talk. I'm interested in when you were talking about, sorry, down here. I'm interested in when you mentioned that the bookmarks were potentially transient and things like that. I wonder if you have any idea for future development where there would be a way to somehow like phase out items over time or something. Because I know that I would save everything and then within a week I wouldn't be able to find anything.
Yeah, that's a good question. So currently for our current developer, we can allow you to search screenshots and or browse the photo albums. And we also consider that with large scales, it will going to be difficult to you recall your past activities. So our current solution just provide you browsing all the screenshots or search them again. So maybe in the future works, we can do more, much a smart algorithm to help you to recall, especially after a really long time, maybe 2 weeks, 1 month, even a year.
Awesome. Our next talk is FeedLens, polymorphic lenses for personalizing exploratory search over knowledge graphs. And presenting today is Harman Kaur, and she is on the job market this year for tenure track faculty jobs and research industry jobs. So definitely get in touch if you're interested. Yeah, so go ahead.
All right. Hi, everyone. I'm Harman. Can you hear me? Okay, perfect. So today I'm going to present a new way to support the personalization of exploratory search for large multi-entity knowledge graphs. So knowledge graphs increasingly form the basis of exploratory search online. They are semi-structured graphs of related entities that allow for faster exploratory search. So for example, a user searching for a new movie to watch might start from the page for their current favorite movie and traverse the knowledge graph to see other recent movies where the lead actors have appeared. Or they can look for a restaurant serving their favorite cuisine in a different city. Similarly, a researcher can navigate the graph of authors, conferences, and institutions to look for relevant literature. Systems that use these knowledge graphs rely on user preference models for personalizing search. So websites maintain a list of previous ratings, clicks, likes and dislikes, and curated feeds of people's preferred content. These form a preference model, which is then used to recommend content. And despite this, exploratory search is still quite complex and cognitively demanding, mostly because of its open-ended nature. We present polymorphic lenses, a technique for effective exploratory search. It repurposes existing user preference models in knowledge graph-based systems to recommend not only the base entity, like a movie or a research paper, but all types and collections of interconnected entities in the knowledge graph, so like actors and directors for movies, or authors and institutions for research papers. For a more concrete example, imagine you, like me, are looking for a new job that will require moving to a new city. If the food scene is as important to you as it is to me, you might want to know how these potential cities rank in terms of your food preferences. So say you have a preference model on Yelp based on your previous ratings of various restaurants in your current city. With polymorphic lenses, you can summarize these restaurant ratings to find a rating for the cuisines corresponding to them. And using that summary rating, you could rank restaurants in any new city based on the corresponding cuisine. Once you've rated the restaurants in a city, you can then use that rating to rank them based on your food preferences. So this type of multi-entity ranking and summarization is enabled by polymorphic lenses. Next, I'll explain how we used polymorphic lenses for a domain that we used for this project, which is the scientific literature search on Semantic Scholar. So the scientific literature knowledge graph includes entities like papers, authors, publication venues, and institutions, which are connected based on various relations, like the written by relation between a paper and an author. The base entity in this graph is the research paper. What that means is all other entities and collections of entities can recursively be described as a collection of papers in some way. So for example, an author can be represented based on the list of papers that they've written. Similarly, a conference can be represented based on all of the papers published in a proceeding. Papers can also be interconnected with each other and be represented using a collection of other papers that cite them. To effectively manage search, Semantic Scholar allows people to curate lists of papers under a theme. So for example, you can rate papers as being relevant or not relevant to your feed, which can be on a research topic. It can be a list of recent research papers or any other theme you want. And Semantic Scholar then recommends relevant content based on the annotated papers in your feed. These curated research feeds are essentially the user preference model that I described before. And borrowing a metaphor from prior work, we refer to these preference models as lenses that people can put together to find relevant content. Using research feeds as lenses, Semantic Scholar recommends other papers not already in your feed that might be relevant to your research interests. With our polymorphic lenses approach, you can extend this by not only ranking, filtering, and organizing the base paper entity, but all other types and collections of entities in the knowledge graph. And we do this to make exploratory search more effective by presenting new exploration endpoints for entities other than papers. To show the utility of our approach, we instantiated polymorphic lenses for the author entity type on Semantic Scholar. So let me show you the end-to-end feed lens experience first, and then I'll go into details of the system design and user study. We'll use specific users, me, my feeds, for interpretability and mental models as lenses for the demo. Now, if I or this user performs a search, the list of papers returned is the same as what you would get on Semantic Scholar. Note, however, the addition of green and purple dots. These dots represent recommended authors that FeedLens thinks are relevant to your feeds. When you hover over a dot, you can see exactly why the author was considered relevant based on this overview chart. This also gives the user an easy way to compare multiple authors at a high level. If the user clicks on an author name, they're taken to the author's homepage, which shows the list of papers written by the author. Now on the left, you can see the same overview chart, but now you can also see exact scores and explanations for why those numbers are there. And this content list also includes the author recommendation dots, so you can continue to compare multiple authors at a high level. We also show the exact relevance scores of a paper on a scale of 0 to 1, and again, upon hovering over the score, you can see the explanation for why it was scored as such. Notice that this list of papers by the author is sorted by relevance for a particular feed. This is one of the feeds that was selected, but you can change it to the other feed and then similarly access recommendations and paper scores for your other feed. All right, so as you could see in the demo, FeedLens features are built on top of existing Semantic Scholar features, trying to integrate with it as much as possible. This was an intentional design decision. We surveyed both Semantic Scholar designers and system builders and end users to finalize FeedLens design. And these final designs come from things that they wanted us to prioritize. So these were things like wanting to support a quick perusal of information by balancing the new content we were adding. We did not want to add so much content that it would distract away from what was already there. We also wanted to embed this in the existing design of Semantic Scholar. And we want to build trust by providing supportive details like explanations for the various scores that we saw so that people could over time trust FeedLens recommendations. All right, so here you can see the author recommendation dots that appeared next to the relevant authors on any list. As you can see, these dots support a quick perusal, so you can quickly tell which author is relevant. And they're embedded in the existing paper row next to the author's name. And they also provide additional details. When you hover over them, you can see the exact scores. Now, I'll only cover this one feature for explaining the system design, but please feel free to read the paper to see how all of the features were designed using the same principles. Okay, so moving on to the details of our user study, it was a within-subject study with 15 participants. We compared the use of FeedLens and Semantic Scholar for a literature review task, where we asked people to find relevant authors and papers based on their research feeds. We relied on the following evaluation metrics: high-level perceptions of the task, like the system usability, cognitive load, the helpfulness of system features, interaction logs, objective and subjective evaluation of the selected papers and authors based on metrics like relevance, novelty, diversity, and obviousness, and qualitative data from follow-up interviews. I won't go over this third set of results since there were only marginal differences between FeedLens and Semantic Scholar for these. All right, so comparing the other metrics, people reported lower cognitive load when using FeedLens compared to Semantic Scholar. They also gave it a higher usability score. They viewed and selected more relevant authors with FeedLens. And based on the interaction logs, we noted that the author-related features had 20 times more engagement. Now, of course, can be explained by the fact that we added author-related features, but even comparing the system-wide features that were consistent between the two, FeedLens features were used along with the system features 4 times more than Semantic Scholar. We had also asked participants to rate the helpfulness of Feedlens features, and most of them were rated over 4 on a scale of 0 to 5. Explanations had slightly lower scores, and participants mentioned that this was because the explanations were pretty high level, so when you were comparing two papers by the same author, they did not offer enough distinguishing information. We analyzed the qualitative data from the follow-up interview to understand the perceived benefits of Feedlens. People noted that it offered more streamlined browsing of papers and authors, which made the task less cognitively demanding. Feedlens features were also more fun and exciting to use, which made people want to continue exploring the content. And finally, it offered a nuanced author selection. So Feedlens always recommended authors who had at least 5 relevant papers to a person's feed. But every so often, it also randomly recommended authors with 1 to 4 relevant papers. And this was done to avoid a rich get richer effect. This helped participants find relevant authors which might be new to a field, like a grad student or someone who's recently changed academic fields, whom they otherwise would have missed. Although we only tested Feedlens for author entities, it's easy to imagine how a similar design could work for other entities in the scientific literature knowledge graph. For example, here's a possible design for conference entities. You can see the relevance scores for each paper based on a user's interpretability research feed. The proceedings are sorted by their relevance scores, and there's an overall score assigned to the venue. You can also get recommendations for authors and sessions using various indicators, and all of this is made possible by polymorphic lenses. And then the idea behind these polymorphic lenses is also generalizable to any knowledge graph-based system. So recall this example where I'd mentioned that you can summarize and rank cities based on a user's preferred food choices. All right, so here are some key takeaways. We introduced polymorphic lenses, a simple but powerful generalization that repurposes a preference model used to describe a base entity type to rank and summarize all types and collections of entities in a knowledge graph. We also present Feedlens, a system that instantiates polymorphic lenses for exploratory search in the scientific literature domain. And we present results from a user study showing that Feedlens is comparable to current search practices, but requires less cognitive load and has a higher user engagement. Thank you, and I'll take any questions.
Awesome. And while we wait for a question, I had one. So oftentimes I might know the senior authors in an area and actually be looking for the people who might have just gotten there. I was wondering if you thought at all about letting users customize some of these things, like the author dots in this case. Yeah.
So the one way in which in the current system people could customize it is if they had different research feeds. So if you had different feeds set up for different authors or recent papers or topic, you could do that. One other interesting thing that happened with senior authors, though, was that our features sorted the feed by relevant papers. So if you went to a senior author's page, it was automatically sorted not by recency, but by what was most relevant to you. And you could change that based on which feed you were applying. So that was something that the participants also appreciated.
Thank you. And let's switch presenters with this last question.
Hi, awesome talk. So this is sort of a follow-up to the same question, but could you expand a little bit more on how you dealt with the problem of skew, which kind of is related to what you were saying with the nuanced author selection?
Yeah, so we're obviously aware of the fact that if we just picked the most relevant authors based on the number of relevant papers, then that would lead to the rich get richer effect. So we always showed them at least 5 authors with at least 5 relevant papers. Our scale was 0 to 20 plus to sort of account for both new authors, medium academic career authors, and senior authors. But 50% of the times, we randomly also showed authors who had 1, 2, 3, 4 relevant papers to avoid the rich get richer effect that I was talking about. Yeah. Thank you.
Excellent. So we have one more talk in this session. It is called Beyond Text Generation, Supporting Writers with Continuous Automatic Text Summaries, and it will be presented here today by Hai Deng.
Okay, hi. Let me get off this mask here. Yeah, my name is Hai Dang, and I'm presenting Beyond Text Generation, supporting writers with continuous automatic text summaries. And I present this work on behalf of my co-authors Karim Ben-Harak, Florian Lehmann, and Daniel Buschek. And so we all already heard from the keynote that writing is a fundamental part of our society and has fundamentally shaped the way we communicate in a society. But I hope you also agree with me that good writing is challenging. And good writing is challenging for many reasons, because it involves many cognitive processes that need to be balanced. For example, during the planning phase, we come up with an abstract idea of what we want to put on paper. This idea is mostly not concrete enough. And so in the next phase, during the translating phase, we are looking at methods into putting these ideas into visual language. So this can involve mechanical tasks such as picking up a pencil and drawing out the letters. And a more digital example for that would be any system that would recommend sentences completions, for example. And then finally, in recent work by Arnold and colleagues, the authors called for supportive assistive writing systems that would help users writing their text, but without trying to correct them or trying to change the content that they are writing. And so to answer this call, we started our design of the tool with the reverse outlining technique, which is an existing writing technique that should help writers to structure the content more. And so this works out is in the middle, there's a text that the user starts writing, and consequently or subsequently, they can start to annotate the text to better understand what is written in the text, and also to write summaries to get a better overview of what is written in the text. And so we were looking into how can we design a tool that automatically creates these summaries at least, and how do users perceive these summaries, and how do they incorporate this information into their own writing process. And so we used off-the-shelf summarization techniques. For example, for the abstractive summarizations, we used the T5 model, which we used from the Hugging Face community. And then we use, for the extractive summarization, we use GloVe vectors plus the text rank algorithm. And so this is the outline of our text editor here. We have on the left-hand side the text editor, which is pretty regular. The user types in the text. But on this right-hand side, you see the sidebar, which creates a separate annotation card for each of the text paragraph that is written in the text editor. And above the annotation cards here, you see different levels of summarizations, including the original text paragraph, the central sentences per paragraph, as well as a abstractive summary of the text paragraph, and also the most relevant keywords per paragraph. And here's a demonstration. As the user writes the text, a new card appears on the right-hand side in the text in the sidebar, and the user can loop through the different summarization levels to get a better overview of the overall content of the text. But one challenge here is that as soon as we have the summarization and the text paragraph on the other hand, there's a mismatch between representation. So the text that is displayed in the annotation card might not necessarily show the representation that is within the text editor. So we somehow needed a way to have a mapping between these two components. And so what we did here is that as the user clicks on different annotation cards here, the text editor automatically jumps to the relevant position and highlights the relevant text paragraph in green. And we also included a functionality that allows users to merge different text paragraphs depending on whether they identified the content of each of them as going into the same direction. And so here's the interactive video where they can drag one of these cards over the other, and the system also shows which part of the initial card will be present in the final summarizations, as well as which part of the other annotation card. And finally, we have implemented a functionality where the users can drag the different annotation cards to reposition or restructure the overall text paragraph and reorder them. Okay. And to evaluate the whole text editor, we conducted an online user study with 12 participants, aged 22 to 36. And the entire study lasted for 60 minutes, where we spent the first 10 minutes to introduce the different functionalities, similar to the functionalities that I presented here. And we also talked the participants through the writing task, which was challenging in a part that we only had a limited time to really test their writing abilities. And so we decided to give them SAT writing prompts, where they basically start out with a source text that they could use to reference for their own writing. And during the essay writing task, which lasted for 30 minutes, we also asked the participants to think aloud so that we can have a better observations of the interactions and what was going on in their heads. And then this was followed with an interview, 10 minutes, and a questionnaire for another 10 minutes. And to derive the interaction strategies and the reflection strategies, we conducted an approach adopting grounded theory, where in the first round, we did an open coding. So basically, we collected all of the researchers' notes and comments into an online whiteboard. And then 2 of the researchers went through all of the different comments and assigned inductive codes to each of the notes. And then in an actual coding round, we clustered all of the different inductive codes and assigned a label per cluster. And finally, in a selective coding round, we went through the transcripts of the videos and the online sessions to find further evidence for the themes that we discovered during the actual coding round. Okay, so the first key takeaway here is that we found that the annotations were used as a reading support and as building blocks. So reading support not only to understand the initial source text. So what the users usually did is they copied the text over to the text editor and used the summarizations and the different levels of summarizations to get an overall better idea of what the text is about, what the source text is about. But they also used the same technique to revise their own writing. So at the end of their essay, they used the summarizations again to get a better understanding of what they have written themselves. And especially one participant noticed that sometimes they start off writing a text and then they return to this text a couple days later. And this kind of tool would help them to just get a quicker overview of their own writing. But of course, they also use these annotations as building blocks for their own writing, where they copied parts of the summarizations over to the text editor and adapted that text to their own writing. We also found that people viewed these summaries as an external view on the text. So that means that especially when the summarizations differed in some way from their own mental summarizations of the model, this triggered an internal process of reflection into thinking about why did it differ, did it make sense, what in this case the NLP algorithm suggested versus what they were writing themselves. And importantly, there is also this one quote here: "It's good to read the paragraph in other wording and slightly summarized." This participant here was actually talking about an extractive summary, which should have used the writer's own words, but still they perceived this as an external view on their own writing. And a takeaway here is probably that low perceived authorship in this sense, which oftentimes take away the agency of the user, actually has a benefit here, because users are able to step away from their own writing and then reflect on the content. And finally, we have seen that some of the participants were using the summaries to check the paragraph scope and structure. So basically, they used the summaries to check whether the summarizations also reflected the focus that they wanted for each of the text paragraphs. Okay, in summary, we contributed a text editor prototype with automatic text summaries, and we conducted a user study with 12 participants to elicit writing and reflection strategies. And furthermore, we highlight that the value of assisting writers with NLP capabilities beyond text generation and correction.
Awesome. We're running just about a couple minutes over, so I'll go ahead and take 2 questions, and then we'll wrap it up. Any questions? Yeah.
Hi, thanks for the talk. I'm Dave Ganesh from Virginia Tech. I was wondering if you had thought about what this might look like for a lot longer form writing, like if you were writing like a novel or a textbook or something.
Yeah, thank you for the question. So obviously in the study we had to limit the writing time somehow, so that was 30 minutes. But we were also thinking about longer forms of text, and especially in longer form of text, such a summarization system would give the benefit of overviewing the text a little bit faster, because the longer the text gets, the more condensed you probably want the summarizations to be. Yeah.
Other questions? Yeah.
Samani from Virginia Tech. I think it's really great work. Thank you very much. It's kind of like more like idea than question, but like I think this could be a writing supporting tool, like where like if the summary does not well represent the paragraph that you have on the left side, maybe it is an indicator that maybe you have to break the paragraph into two paragraphs so that it better reflects the paragraph. So I think the third point that you make, like people have been already finding some benefit in that. So I don't know how the NLP algorithm works. Maybe it could be represented as a score, so that like whether the summary well represent the paragraph or not, that could be an indicator to suggest that hey, maybe we can break this into two paragraphs, and then maybe that in that case maybe summary score will go up and better represent the structure.
This is also actually a interaction that we observed during the study, that not only did the participants try to integrate the summarizations into their own writing, but they also actively adapted the text editor, or the text written in the editor, to kind of modify what was outputted by the summarization algorithm. So exactly, they split up text paragraph if they felt that it contained more, if the scope was not narrow enough. Yeah.
Awesome. Thank you so much to all the speakers for the really great talks. Let's give all the speakers one more round of applause. And hopefully they'll stay after a bit if you have more questions. I think we're going to a coffee break now. Yeah.
because we're opening up. Yeah. Oh, okay. This wall will be back, yeah. We got to take that out to get that.